It is to acknowledge our reverence for wisdom and knowledge by lighting the lamp of enlightenment. We invite the chief patron, Dr. Jasmina, our principal,
இது
to do
ஓபன்
the
பண்ணி
honors
பார்க்கறது
as
எப்படி?
we officially commence
நம்ம
our
ராணி
day.
என்ன அந்த இதில் போய் பார்க்கலாம் இந்த யூடியூப்ல அதில் போய் லைவ்ல எடுத்தோம்.
We are honored to have our chief guest, Dr. B. Sundararaman sir. May we request you to light the lamp, sir. We also warmly welcome the patron, Dr. J. Daisy Magdalene, to add their light to this moment of grace. Moving ahead, it is my pleasure to call upon our resource person, Dr. T. It's my pleasure to call upon our resource person, Dr. T. Daniel sir, to join the speeches. I invite the convener, Dr. S. Valimina ma'am, to complete the circle of life with your wisdom. As we commence this significant event, it is only fitting that we begin with the words of welcome from the patron, Dr. J. Daisy Magdalene ma'am, head of the physics department, whose insights and wisdom truly resonate with our purpose today.
A very good morning to you all. Today is a red letter day in the history of Physics Department, Rani Anna Government College. We have finally reached no balls in hell. Our maiden venture into making this conference have become a reality. My joy knows no bounds. So far, so good, and I'm confident we maintain the same tempo and return home with a sense of fulfillment. Dignitaries on and off the dais, my dear staff from the physics department, and my dear students. As we raise the curtains for today's event, I proudly stand before you to deliver the formal welcome address. First, I would like to welcome our dear principal, Dr. Sunita, who will be presiding the inaugural function. Honesty, straightforward, genuine. These are the words which cross my mind when I think of her. Concerns of the college, major or minor, it's her utmost priority. She never shies away to face the challenges she has to as the head of the esteemed institution. In a government college, though things are not in her control, she has the fortitude to face all storms like a sailor to navigate the waters. She tries to make the impossible possible. Even when she was a staff, I have noticed how boldly she speaks and stands against injustice. Above all, she is a wonderful human being, very godly empathy. Nobody is high or low for her. She saw human dignity in all. Any activities in college, not only she gives a go-ahead signal, but supports us in all possible ways. Our Rock of Gibraltar. Ma'am, we are extreme. You have graced this occasion with your presence, and we the staff Next, I am extremely privileged to welcome the chief guest of the inauguration ceremony, Dr. Sundararaman. Dr. Sundararaman is no new face to us. He is a very good friend of our department, and he is a research guide of Dr. Esther. Esther always have very regard for him, and if she gets a chance, she never fails to seek praises of him. He is an expert in his field, ferroelectrics, piezoelectrics and magnetic electric composites. Professionally, he is a perfectionist who demands perfection from his research scholars. Honesty is his best policy. He appears calm, but more depth and less waves like the mighty Pacific Ocean. It's true, true wisdom remains silent yet profound. A renowned man of high repute who doesn't like to delegate his works but does everything on his own with utmost dedication. Sir, your inaugural address will definitely give a colorful start to this conference. On behalf of the staff and students of Physics Department, Rani Anna Government College, we extend you a hearty welcome. My welcome is due to Dr. Daniel, keynote speaker of the first technical session. It's a natural human tendency to remember the first. Sir, you are the first keynote speaker in the first technical session in the first conference organized by your department, and your name will sure be engraved in our minds. An enterprising researcher, he made his first steps in research in Marumminiam Sundanar University. From then on, he was going on adding more feathers to his cap, making giant leaves and carved a niche for himself. His accomplishments in research is incredible, and Esther is his friend. And when I asked him what his hobby was, she told that she sings well, and of course I hear him silently happy to welcome you, sir, on this platform. Next, I would like to welcome the convener and organizing secretary of this conference, Dr. Vallimina and Dr. Esther. We didn't have much time. In a limited time period, their confidence and perseverance made this occasion possible. For the past 2 weeks, they both were always sitting in a corner, chit-chatting with serious faces, planning and assigning the jobs to their colleagues. It was so cute. Tough but fat taskmasters they are, who expected perfection from anyone, always pushing the whole team to achieve their best. The souvenir especially is the fruit of their tireless effort, resilience and skill. My special welcome to you both. Their hands with the convener and gave them full cooperation in spite of their personal hurdles. They worked hard, worked wholeheartedly for the grand occasion. Teamwork makes the dream work. My hearty welcome to you all. Finally, my dear students, I welcome you with a heart full of love. Students from our college and from another college, you are our joy and pride. Ultimately, conference is organized and inspire and enlighten your young minds. In fact, this is a great opportunity for you to be in the presence of talented and accomplished individuals, each of whom bring their own unique perspective and expertise to this platform. Once again, I welcome you all, and let's make this conference a memorable and productive experience for all of us. Thank you.
Thank you, ma'am, for setting the tone of the conference. We would be delighted to invite our Chief Patron, Dr. J. Sunita ma'am, our Principal, a renowned educator and administrator, to present the presidential address.
Good morning, honorable present here. First of all, I would like to congratulate the Department of Physics to arrange such a beautiful and wonderful conference. Of course, physics is considered as the king of all science, and it is making new innovations now and then. And you all know, every year Nobel Prize is given all over the world, selecting the major contributors to the world of physics. So, this field of physics, it is a very innovative area, and it needs more research to bring out the novel ideas behind it. So this conference is one such attempt to make known about among the students community about the recent trends and innovations in the area of in the various areas and specializations of the physics department. So once again, I would like to congratulate the HOD and the conveners and the organizing secretaries of this conference, and I wish all the success to this conference, which is a major motive and enthusiastic effort of the Department of Physics. Thank you, one and all.
Thank you, ma'am. Your leadership and vision have been instrumental in shaping our institution's academic excellence. Now it is our privilege to honor the dignitaries on the dais as a humble gesture of our respect. Now we would like to invite Dr. J. Daisy Magdalene ma'am to honor our principal, Dr. J. Sumita ma'am.
เป็นอินฟอร์มอะไร கொடுத்துருக்கீங்களா கிடைக்கலன்னு சொன்னாங்க
We would like to request our Chief Patron, Dr. J. Sumita ma'am, to convey our deep-seated gratitude to our Chief Guest, Dr. B. Sundarakanan sir. It is with great pleasure to invite our Chief Patron, Dr. J. Sumita ma'am, to honor the resource person, Dr. T. Daniel sir, as a humble gesture of respect. We would like to invite Dr. D. Devjindi ma'am, Assistant Professor of Physics, to kindly introduce our Chief Guest, Dr. B. Sundarakanan sir.
It is an honor and privilege to introduce Dr. Sundarakanan sir. He is a well-known person to our department. We often call him for DC meetings and other occasions. He always accepts our invitation cordially. So I feel that I am introducing our very old Gladiana family member. He is presently working in the Department of Physics, Manomaniyam Sundaranath University, Tirunelveli as professor. He has obtained PhD from University of Madras, Chennai, and carried out research work in Material Science Division, Indira Gandhi Center for Atomic Research, Kalpakkam. He is a recipient of JSPS Fellowship from Japan to carry out research in Nagoya Institute of Technology, Nagoya, for 2 years. He also did postdoctoral work at USA. His area of research is ferroelectrics, lead-free piezoelectrics, multiferroids, and magnetoelectric composites. He has guided 7 students for PhD and 24 students for MPhil. He has completed 4 projects from UGC, CLSR, UGC, DAE, CR, and SERV CST. To his contribution, he has published 62 publications in international journals. His height index is 19 and height index is 33.
Thank you, ma'am. It is our great pleasure to welcome our Chief Guest, Dr. B. Sundarakanan sir, Head of Department of Physics, Manomaniyam Sundaranath University, to enlighten the inauguration with his inaugural address.
The last chapter.
Hello. Good morning. I'm really happy to stand in front of you to give a keynote address for the conference, international conference organized by Department of Physics, Rani and College. I'm surprised to know that this is the first conference, and I wish the department and faculty members to arrange many more such conferences, because it is easy to get resource persons online as well as offline. So, because that will benefit research scholars and students of this institute and across other institutes. And I take this opportunity to thank the organizing secretary, Dr. Esther, for giving me this opportunity, and also convener, madam, and
A milestone cross. This day for sure is a red letter day in the history of physics department in our college. A moment of joy and fulfillment. Of course, a dream come true. A maiden effort by the staff and students of our department. We are delighted to announce the official release of the proceedings from our conference, a comprehensive compilation of cut-edge research, innovative ideas, and expert insight from our fellow visionaries. We would like to invite Dr. J. Sumitaman to officially release the proceedings of the conference in this momentous occasion. I request the students to stand up and clap your hands. We express our deepest gratitude to Dr. B. Sundararaman sir for their pivotal role in receiving the proceedings. Thank you, sir, for your unwavering support and presence, which has been instrumental in the success of our conference. Thank you to our authors, reviewers, and editors for their hard work and dedication for making this publication possible. We hope you find the proceedings informative, insightful, and inspiring. Let's give a big round of applause.
Students, please.
So, once again, good morning. So, and I think I start with thanking convener, and it is my time to thank the HOD for giving me this opportunity, and other faculty members, including Pravina, my wife. Dr. Daniel, who was our hardworking student. The topic is photoelectrochemical water splitting using ferroelectric oxides for green hydrogen generation. Hydrogen is why hydrogen? Why do we need hydrogen? That is a main question to be asked. And hydrogen is termed as energy future fuel. So, for example, why we need hydrogen? We pay electricity and we pay gas connection. We spend money on buying petrol and diesel for transport purpose. All the three can be met from hydrogen. Electricity can be generated from fuel cells, and hydrogen can be used as in place of LPG cylinder. Hydrogen can be used, and hydrogen can also be used to run a two-wheeler and four-wheeler. So, therefore, hydrogen is unavoidable future energy material. Presently, we use diesel, petrol, and electricity is generated from thermal power stations, nuclear and hydro power stations. Almost 60% of the power generated in India is from thermal energy. That means thermal reactors. By burning coal, we generate electricity. And using dams at the mountains, we generate 20%. And renewable energy is close to 16%. From nuclear reactors, almost 22 nuclear reactors spread across India, close to 4% only. So this percentage is all India generation capacity, electricity generation capacity of India, which is available in Central Electricity Authority of Government Department. You can download it. Every day, executive report can be downloaded. You can download and learn the latest developments. So therefore, by reducing the electricity generation by thermal reactors, we can save the environment, emission of gases that spoils environment. So this green hydrogen is generated by solar radiation. That means using sunlight, then it is called green hydrogen. So this green hydrogen at present are generated by, there are a nomenclature is done with colors. If you, from natural gas, if you generate, it is called grey hydrogen. From steam reforming, if you generate blue hydrogen, and this is the green hydrogen, renewable energy sources such as solar and windmills, if you use and generate by electrolysis process, then it is called green hydrogen. And there are other ways by which you can generate, and these are gasification. The coal is used, that is black hydrogen, and pink is from nuclear, and turquoise is from natural gas, and this is again from solar energy. But the topic of interest is green hydrogen. So next slide. So I said hydrogen is is the fuel of future. So therefore, hydrogen can be generated from water molecule. Water consists of oxygen and 2 hydrogen atoms. Now this is 4 bytes diagram. So x-axis is pH and y-axis is potential with reference to standard hydrogen electrode. And look at this graph, 4 points. For example, consider this point. So in this point, hydrogen, 2 protons are reduced into by consuming 2 electrons, and protons are reduced by hydrogen molecule. So in order to create one hydrogen molecule, you need 2 protons and 2 electrons. But if you increase the pH from 0 to acidic to base, then you need again you need 2 electrons, and water is reduced and you produce hydrogen. But for oxygen generation, you need oxidation process that consumes 4 electrons and 4 hydrogen and 1 O2. You get generate by oxidizing hydrogen water molecule, you can get oxygen. Similarly for other, by oxidizing OH ion, you can get oxygen. So this region is completely oxygen. Below is hydrogen. This is the equilibrium of oxidation. This is the equilibrium of reduction process. So the point is, one has to supply close to 1.3 electron volt if you supply. So from this point to this point is 1.3 volt if you supply. Between 2 electrodes, you can expect water to split, oxygen and hydrogen will bubble up. So now, this is theoretically it is 1.3, but in practice you need to give additional voltage, that's called overpotential. Instead of 1.3, 1.23, you may have to give 1.5 or 1.6 electron volt, just volt. You can and add an electrolyte in water. You can see hydrogen and oxygen are bubble up from the electrolyte video. Next slide. You can play the video. So this is a simple video generated by MSc student. No, the other video. First, yes. You put escape and please go to PPT. Please go to PPT. Okay.
Video.
Yeah. Please. Yeah. Yeah. Audio. So can you replay from the beginning? Okay. This video was recorded by an MSc student, Fancy and Sakina. Audience. Okay. So, can you play completely? Okay. So this is a 9-volt battery, and you have got 2 terminals, positive and negative, and the red color being a positive, it is connected to photo anode, and which is copper wires. And so this is connected to copper wire. Both electrodes are copper wire, and negative terminal of the is also connected to. We have a water in which is sodium sulfate, 1 molar sodium sulfate is solution is the electrolyte. And the moment you apply potential to this 2 electrode cell, you could see the bubble from positive electrode. This is oxygen, and you could see you can see small bubbles are coming up, right? So these bubbles can be, now we have connected an ammeter in series, and then we could measure something like 70 milliampere current is consumed for this electrolysis process. Next slide. Okay. So now we multimeter, using ammeter, we got a reading of 70 milliampere. Now this can be converted into how much amount of hydrogen generated. So you can divide this current by area. This is a cylinder because cylinder area is 2 pi r, and this is length 2 pi r h. Area of the cylinder is 2 pi r h. So by dividing this, you can get 35 milliampere per centimeter square. Now we know that current is dq by dt. When rearrange, you integrate both sides for 1 minute, that is 60 seconds, and the current is 70 milliampere. So you get 4.2 coulombs. So 1 electron equal to this much coulomb, and 1 coulomb is equal to these many electrons. Now number of electrons in 4.2 coulomb. Hello. Number of electrons in 4.2 coulomb is equal to 4.2, and this you get these many electrons. Now we know that in the previous slide I told 2 protons consume 2 electrons, and you get 1 hydrogen molecule. So therefore 2 electrons are required for the formation of 1 hydrogen molecule. So you know these many electrons, and if you divide by 2, you get how many number of hydrogen molecules. These many number of hydrogen molecules are generated. 1 mole of hydrogen is equivalent to Avogadro number, and the amount of H2 generated is equal to these many micromoles. 22 micromoles are generated, and you wanted to convert this micromole into liter. So molar volume for any gas at the standard temperature and pressure occupies 22.4 liter. So if that is the case, then 1 mole is 22.4 liter, means 22 micromole is how much? So 22 micromole of hydrogen corresponds to close to 0.5 ml. So the point is, in 1 minute water electrolysis with the 9 volt battery with a current density of this much produce 0.5 ml. So this is 1 minute 60 seconds. So now you can increase the time, you can increase the amount of hydrogen. So this using this simple equation, we are able to reduce how much amount of hydrogen generated. So next slide. So the same thing, instead of copper wires, they have used 2 different materials. Consists of molybdenum oxide, nickel 4, and these are used at both anode and cathode. And you could see the amount of volume. You see, check the volume of oxygen and check the volume of hydrogen. It's almost twice is generated. And again here is they also use a AA battery which is connected to this, and you could see hydrogen is generating. Instead of copper wire, they use different materials. So next slide. Okay, so this is about electrolysis. Now next, what is photoelectrochemical hydrogen generation? Because ferroelectric materials are known to possess spontaneous polarization. That means they have intrinsic dipole moment, And if you divide dipole moment by volume, you get a polarization. This polarization can be flipped or switched by applying external electric field. Now they have been used as sensors, they have been used as RAM memories, but recently means past 10 years, 15 years, people started to use ferroelectric oxides as the electrode material for the generation of hydrogen. So these are 4 important reviews that has come. This 2018 and then 2020, 22 and very recent 2025 February. So these articles, from these articles I try to summarize what is the development made of using ferroelectric materials. Next slide. So these are the progress made on ferroelectric materials on photoelectrochemical hydrogen generation. For example, this is lead titanate. The material that we are working is barium titanate. You could see that the single crystals are got and piezo catalyst, and again barium. It is BFO barium titanate, and again sodium bismuth titanate. So the progress is developing rapidly, and therefore the purpose of this slide is to say that even if you start working on ferroelectric materials consists of barium titanate and sodium bismuth titanate and bismuth ferrite, you could use this knowledge and start your own research. Next slide. Yeah, this is again the photoelectrochemical performance outputs of many of the ferroelectric materials, for example, bismuth ferrite, potassium niobate. Consider these two consist of barium titanate, and this is cerium doped barium titanate. You can see that these are cold, and this is the potential, and what kind of 1 mole of sodium hydroxide was used, and the band gap is because this is a high band gap. 3.25 electron volt, barium titanate is 3.25 electron volt. It was reduced to 2.73 because the cerium was low. And the remnant polarization. So this is the amount of current that is coming out. In this case, it is 1.23 electron volt. And the photocurrent is, you see, this is very few milliampere. That's almost 1 milliampere only coming out from barium titanate. So that is the target. So you could, if you can prepare barium titanate by proper method, and if you can increase this current density from 1 milliampere per centimeter square to higher, that is 10 milliampere, 10 times if you can increase, then that is you have achieved your target, and that methodology or the know-how can be translated from laboratory to pilot plants. Because if you wanted to, there is a paper recently reported, if you wanted to commercialize the hydrogen generation, green hydrogen generation using photoelectrochemical process, there are 3 points you have to achieve. 3 target points. First is you have to produce 10 milliampere per centimeter square current density. Second point is your whatever generated current should not decrease as a function of time. Even if you use for 3000 hours, the current can decrease by 10%. Then you have achieved second point. And your electrode area should be 10 centimeter squares. That third point. If we can meet all these 3 targets, you have I think I would use the word, you have achieved the main result, which you can go for commercialization. So next slide. So in this slide, this is particulate photocatalytic reactions. The problem here is both hydrogen and oxygen are evolved together, and you may have to separate hydrogen and oxygen. So this is a lot of people are working in this, but the problem is this. But this is a semiconductor based photoelectrodes. Particularly this is photoanode and this is photocathode. And here metal is used such as platinum. Mostly people use platinum. And this is novel photoelectrochemical water splitting, which applies photovoltaic plus photoelectrochemical. It's a hybrid system because we need to supply the potential of 1.23 electron volt. That will be supplied from photovoltaic solar cell to the photoelectrochemical cell. So therefore, from externally, from the TNEB grid power, you don't have to give. So you can use this configuration, place it on your roof of the building, then you can generate hydrogen. That hydrogen can be stored in cylinders. When sun is not there, you can purge that hydrogen that is stored to a fuel cell. You can generate electricity, which can be used during night time. So that's the purpose. Next slide. So here, again, so this is the configuration with the single photoelectrodes. The other one is platinum. And this is the configuration where both the photoelectrodes, that is photocathode as well as anode, different materials are used. And we started work on this configuration, that is a single photoanode, and platinum will be used as a photocathode. So in this photoelectrochemical water splitting, there are three processes. Process one is light has to be absorbed by the material. Because light absorbed, then an electron from valence band will be excited to conduction band. Therefore, holes will be created in the valence band. Similarly, electrons will be created in the conduction band. Now that electron can be used. Already I told you, 2H plus 2 electron gives H2 molecule. So 2 electrons can be used for reducing the proton. Similarly, the hole can be used to reduce, to oxidize and generate oxygen. So this is the mechanism that is used. So this yellow color is your material in the form of particle, where the electronic band structure is 2 vertical lines are electronic band structures. And this is the sequence of process happening in the material when sunlight falls on the material. So your end has to be such that your material has to be good absorbent, that all the photons coming from solar sunlight has to be absorbed by the material. The moment electron and holes are generated, they should not recombine. Previous slide. They should not recombine. So immediately you have to transport the photo-generated carriers for the reactions. So you must have active sites at the surface of the photoelectrodes, so that the electrons will be taken by external circuit to the platinum, where the reduction process happens. Hydrogen is generated. Here, what oxygen is, this oxidation is taking place, and oxygen is generated. So in this process, you can have intermediate, you can have a PEM, proton exchange membrane, by which the protons will be permeable through that membrane, and you can separate into 2 chambers. One is for hydrogen generation, another chamber is for one is for oxygen, other is for hydrogen. So you don't have to separate whatever bubbles that is coming out. So this side will be oxygen coming, this side hydrogen will be coming. So next slide. Now, what are the potential ferroelectric materials that I can work? So before going ferroelectric materials, the property of the ferroelectric material is given here. The x-axis is electric field, y-axis is polarization. So x-axis means independent variable, always you can change it, and y-axis dependent variable. By changing the electric field, you can change the polarization, you can increase the polarization. So what is this diagram, what is this, and what is this diagram? So you could, before Polling. Polling means applying electric field to the sample. That's what polling. These arrows are nothing but polarization vectors. They are randomly oriented in different domains. The domains are inside the grains. So these domains will respond to the externally applied electric field. For example, what is the electric field? Potential difference divided by distance. So this is the distance. This is the positive electrode. Bottom is negative electrode. If you connect a DC power supply, then increase the DC power supply slowly. That means you are increasing electric field. So in this process, you are aligning the domains and the domain growth and at some point of electric field it starts saturates. So this is called the saturation polarization. And when you reverse it, and the polarization can be reversed and maximum in the reverse direction can be achieved. And again it can complete it. This is called as ferroelectric hysteresis loop. Similarly, for magnetic material also, you might have come across H versus M. X-axis is applied external magnetic field and y-axis magnetization. Similarly, you can also have stress and strain curve. That is one of the ferrite property. Magnetic, ferroelectric, and then ferroelastic. These three all have a hysteresis loop. And so what is this curve says? That is what given here, strain, and when you apply electric field, strain means what? Delta x by x. That is change in dimension by application of electric field. So now, what is this graph tells? There are, see the red color one are valence band and the green color are conduction band. So now there are two dotted lines which tells about the difference between these two dotted lines is 1.23 volt. Initially I told that's the theoretically minimum required potential for splitting a water molecule. That's ideal voltage, but you need to supply more over potential of say 0.3 volt or something like that. So now if you can see, if this water splitting has to, what one can learn from this diagram. So for example, your material must have the conduction band must be more negative compared to the hydrogen reduction line. Similarly, your valence band has to be more positive because this scale, this side is negative axis and this side is positive axis. So your valence band has to be more positive. Similarly, your conduction band has to be more negative. If you find such a material, you can work on that. So that to decide that which material one has to work, this graph is given. Now we have chosen to work on barium titanate, where it's slightly above the more negative than the required hydrogen reduction potential, but it is more positive with reference to valence band. And we know how to prepare this barium titanate. For 15 years we are working on this. So it is start with what we know. So therefore we decided to work on this material, and also decided to work on this material, bismuth iron oxide. So this also we have worked for 10 years on different purpose, because this hydrogen generation is a new perspective of ferroelectric materials. So therefore, so what this graph here we say that this axis is solar to hydrogen generation efficiency, and this is photocurrent density. The efficiency is very low, that is 1%, 2%. The maximum, I think, less than 5% is what reported. Even if you get a material which can give STH efficiency of 5%, that is another thumb rule where you can start a company. So targets are very clear. You must have 10 milliampere current density. Your photoelectrode must be stable for 3000 hours, and your electrode must be 10 centimeters square area. And efficiency, anything more than 1% is you made an achievement. You can start a company. So next slide. So this is again explanation of platinum, one electrode, that is electrode, and you can have high heterostructures or bilayer thin films. This is a ferroelectric material. This is a current collector made up of any conducting material. In between you have titanium dioxide layer, so that as a function of time this does not peel off, and this will also contribute to the photocarrier generation. So photocarriers will be generated in ferroelectric material as well as in titanium dioxide, and both the photocarriers, that is electrons, can be taken through an external wire to the platinum where protons are, two protons consume two electrons and create one hydrogen molecule. So this setup is, you can also make a particle and co-catalyst. You can deposit a material, silver or platinum is another material. Metals can be deposited on the larger ferroelectric materials. So that is another method, but again the problem here is the hydrogen as well as oxygen will be generated together and you have to separate them subsequently. So this is not a good method, but we will go with that. So next slide. Yeah, I think I presented, first I presented electrolysis using battery system, how hydrogen and oxygens are generated using a one. You can also do this experiment by buying two 1.5 volt batteries, two copper wires, that is all you need, you can generate, and 1 mole of sodium sulfate solution, or sodium hydroxide solution. That video you have seen. And then I presented 4 recent review articles in the literature published 2018 to 2025, last month. And the main results are summarized, particularly the target for from laboratory to translate the results that you obtain from laboratory to the industry. The targets I have, literature it has been told, that I have specified to you. With this knowledge, the MSc students have done some work using varied technique. The next video is that. I have not worked the hydrogen generation past 15 years. Only November I started, and we have come up to this level. This work was not done by research scholars, only by MSc students. I repeat again and again because the purpose of the conference is to inspire students and research scholars. So therefore, I stress that MSc students of MSc University is doing, if they can do, you can also do, because we have got good faculty members to guide you. So if one or two students can inspire and decide to do research, then that is the success of the conference and the effort taken by Esther and Malina Madam. So let us go to video. With that, I will complete my presentation. Audio is nalla because the MSc students spoke. Yeah, this is the audio. Okay, so this is the stainless steel substrate. Okay, this is the reference electrode. This is reference electrode, and this is counter electrode platinum. This silver chloride reference electrode. This is the cell that is used, which has 1 mole of sodium sulfate solution. This is xenon lamp, and instead of sun, we use xenon lamp because like mercury will give a wide spectrum. And this is a CD instrument, a CH instrument available at the Department of Physics. And there are 4 electrodes and a working electrode. And the counter electrode and then reference electrode. And these electrodes, so without light you have to measure. So these 3 electrodes are connected to, this is counter electrode, and that white color is reference, and this is working electrode. Now in order to do that, the students have done, they have taken a small enclosure consists of cardboard. Inside they kept it, and she is going to close it now and carry out the measurement. So this is a cyclic voltammetric curve. Now you see the potential range, see the x-axis, see the y-axis, look at the units, and look at the time that is running. So potential is varied. If you in the experimental parameter, if you give the rate, you will vary accordingly. Once reach the maximum potential, it will come back in the reverse direction. It will be reducing. That's why it is called cyclic voltammetry. And you can do this. Now this is a linear voltammetry. The same instrument, same setup, only the measurement parameter is different. So from this you can estimate, so this is a Nyquist plot, real part of the impedance and the imaginary part of the impedance are plotted and it can be measured. From this you can find the series, the resistance values and charge transfer resistance by fitting this curve using equations, using complex function fitting. There is a software which is available and you can use equivalent circuit. Using that you can extract some parameters. Next slide is Bode plot, where x-axis is the frequency of measurement and y-axis is the real and imaginary phase value. And this is chronoampermetry. As a function of time, the potential is applied on and off. So these all are 4 measurements done in the dark using the electrochemical cell. So now this is actual photo. Now the xenon lamp white radiation is falling on the SS plate. On top of the SS plate, the students have coated barium titanate, and you could see the amount of hydrogen that is evolving. This is really encouraging. That one is oxygen. This one is hydrogen. So the 4 graphs again will be shown. This is a cyclic voltammetry and then linear switch voltammetry. So again, the evolution of bubbling of hydrogen and as well as oxygen. Chronoampermetry. So Nyquist plot and Bode plot. Okay, this data was taken only last, I think Wednesday or Thursday, and we will be comparing dark and photocurrent, do the analysis, and we will check what people have reported and how much we achieve with photocurrent density. And then also we can do a lot of measurements. We can do mass Schottky plot and measure the interface. There are many what's possible, because now this is a pure barium titanate, band gap is higher. We know that iron and niobium, if you substitute close to 15 mole %, your band gap can decrease from 3.25 electron volt to 2.55. That means you can increase more visible radiation. Still you can increase the absorption of sunlight absorption by the material will be increased. That means you can create more number of electrons and holes. If you can create more number of electrons and holes, you can create more amount of hydrogen. So many such works are possible, and I would like to say that Tirunelveli, before last week, Tirunelveli as the largest solar panel and cell manufacturing plant, which is Tata Power Solar, located at Gangaikonda. It is 4.3 gigawatt factory, which is largest. Only last week, a plant at Uttar Pradesh, Gurgaon, overtook that. And India has pronounced National Hydrogen Mission, Green Hydrogen Mission. Using that, we can expect green hydrogen hubs. I predict Nanganeri soon will become a green hydrogen hub because Tirunelveli already attracted solar, and hydrogen will also be attracted by Tirunelveli because of strategic location. The Nanganeri Special Economic Zone is strategically placed because you have Kavalkinaru, ISRO, and we also have Navy, and we also have port. Therefore, down next to 5 years, after 5 years to 8 years, one can expect Nanganeri, you will have a green hydrogen hub. And I told in the beginning, you need, you pay your money salary for electricity, for gas, and for petrol and diesel. All the three can be done if you have a hydrogen generation. Assume it will not be a surprise 15 years down, from next 15 years or 10 years, each house will have a solar panel and this kind of hydrogen generation and storage facility and fuel cells. So you will be, you will not be dependent on the government for electricity, for gas connection and for petrol. So that will happen. Surely it will happen next after 10 years to 15 years time. So therefore, the point is there is plenty of opportunity to work on hydrogen, particularly green hydrogen. If you are a research scholar, you can, these videos I put because this is not a tedious experiments, and the preparation of barium technique is done with the ordinary research plate. This kind of plates, you can coat it with just using knife, you can put a drop and then shear it, you can form a thin film and then you can prepare. And this is scalable, easy, economical. Therefore, you have to work on such a technique. Then only you are really working for society. You don't need sophisticated instruments like pulse-laser deposition or MOCVD or MBE. This is a simple method, so you can do a lot of research, particularly the experience we have with the ferroelectric materials. We are expected to produce, I think we hope we will produce good results soon. Once again, I thank Esther and Valimina ma'am for giving me this opportunity. There are, I think I took 40 minutes. If there are some questions, I will try to answer. Otherwise, Okay, I think you may have a lot of questions, but you can ask your teachers, they will answer. Thank you. Thank you.
Thank you, sir, for your profound and illuminating presentation, which has undoubtedly set a compelling tone to our conference.
Gratitude is a sign of noble souls. To that note, we cordially invite the convener of the conference, Dr. S. Valimina ma'am, Associate Professor of Physics, to deliver the vote of thanks.
Good morning. Dear esteemed dignitaries, honored guests, elected delegates, faculty members, research scholars, students, and everyone present here today, a very good morning. I stand before you with profound gratitude and heartfelt appreciation to express our sincerest thanks to each and every one of you for making this international conference a monumental one with our gracious presence. Especially, we offer our gratitude to Dr. Daisy Magdalene, Head Department of Physics, for delivering a warm welcoming address that embarrassed us with all openness and hospitality. Dr. J. Sumita Ma'am, Principal, Rani Anna Government College for Women, for her inspiring presidential address that ignite our passion for knowledge and collaboration. Dr. Sundarakanan Sir, Professor, Head, Department of Physics, Manoormaniam Sundarlal University, for sharing groundbreaking keynote insights that broaden our perspectives. Dr. Daniel Sir, Assistant Professor, MBJ College of Engineering, Bangalore, for going to contribute valuable expertise as resource person and enrich our understanding. Thanks to organizing committee members, volunteers, research scholars and staff of our college as well as other colleges for their tireless efforts. Once again, I would like to convey my deepest appreciation and sincerest thanks to all concerned. Thank you.
Thank you, ma'am. As we set out on this intellectual journey, we hope that the conference will offer all attendees a plethora of insights, enable fruitful interactions, and inspire fresh perspective about the topic at hand.
Now moving on to our technical session 1, we are fortunate to have with us today some distinguished speaker for moving on to our technical session 1, we are fortunate to have with us today some distinguished speakers who are noted figures in their field will present their research and findings. We request the convener of the conference, Dr. S. Vallimina Ma'am, to introduce our resource person, Dr. D. Daniel Sir.
Once again, good morning. Physics is the belief that a simple and consistent description of nature is possible. Here is an academician who has proved that physics is the master of all sciences. Our resourceful resource person is a brilliant designer of physics. To the delightful of Mr. Dhanabali's family, he was born on 28 May 1982 as a star to shine. This 92 as a star to shine. This physics shine has completed his PhD from the Shrine of Education, Manoormaniam Sundarlal University. He has been awarded JRF and SRF during his PhD. Our resource person seeks to inspire, mentor and explore nationally and globally. His specialties bloom like flowers in spring. Material science, thin films, photovoltaic materials, nanomaterials for energy storage are the fortes of our powerful professor. He is an educator with scintillating skills, researcher with an aura of hope and a guide to great horizons. He touches the academic sky with 23 publications, 152 citations and 7 high-checks index. Presently, he is proudly serving as Assistant Professor, MBJ College of Engineering, Bangalore. All this credit goes to our resource person, Dr. D. Daniel, a name that has imbibed in proudful physics. Thank you once again. I welcome you.
Our first session, metal chalcogenide thin films, a promising avenue for next generation solar cells, will be chaired by our resource person, Dr. T. Daniel Sir. The session is over to you, sir.
Thank you, ma'am. Thank you for the opportunity. ஒரு 5 to 10 minutes மட்டும் நான் தமிழ் அப்புறம் நம்ம டாபிக் போயிடலாம். First of all, my sincere thanks to the organizers, Vallimina Madam, Head of the Department, Principal and Dr. Esther Bodhi. Because எனக்கு தூத்துக்குடியோட திருநெல்வேலி ரொம்ப பிடிக்கும். ஏன்னா நான் எம்எஸ்சி, எம்ஃபில், பிஹெச்டி ஆல்மோஸ்ட் 10 years நான் ஸ்டே பண்ணது திருநெல்வேலியில் தான், எம்எஸ் யூனிவர்சிட்டி ஹாஸ்டல். ஈவன் என்னோட 2-wheeler நான் எடுத்தது திருநெல்வேலியில், பட் ரெஜிஸ்டர் பண்ணது தூத்துக்குடியில். 2-wheeler நான் தூத்துக்குடியில் ஓட்டுனதை விட திருநெல்வேலியில் ஓட்டுனது தான் அதிகம். எந்த மக்கள் எந்த போலீஸ்காரங்க நிற்பாங்க, எந்த சந்தர்ப்பத்தில் போனால் எந்த இடம் வரும். ஸோ இன்னைக்கு காலையில் ரொம்ப நாள் அப்புறம் திருநெல்வேலிக்கு நான் வந்திருக்கிறேன். ஆல்மோஸ்ட் ஆஃப்டர் 5 years நான் இந்த சைடு வரேன். வரும்போது ரொம்ப சந்தோஷமா இருந்தது. அந்த கேடிஸ் நகர் தாண்டும் போது அப்படியே என்ன சொல்ல அன்னைக்கு எக்ஸ்பிரஸ் மை ஃபீலிங்ஸ். அப்புறம் டுவர்ட்ஸ் ஜங்ஷன் ரெட்டபாலம் அப்படியே எனக்கு ஒரு ஸ்டூடெண்ட் நிலைக்கு எடுத்து போயிடுச்சு. அவ்வளோ ஒரு ரொம்ப ஹாப்பியாக இருந்தது. Thank you. Then, yeah. Okay. Going to the talk. Basically, my research area is thin film photovoltaics and photochemical cells. Apart from that, I'm doing some researches based on solid oxide fuel cells, SOFCs. There is some theoretical research also going. Yeah. Basically, I'm from a fisherman family. My parents, they don't know how to write ABC. Because of my parents, I'm standing here in front of you guys. And I'm the first to graduate. And yeah, during school time, I no started but now, in the solar, I'm going and coming by my own four-wheeler. எல்லாத்துக்கும் ரீசன் என்னன்னா படிப்புக்கு மேல நம்ம தாய் தகவலுக்கு நம்ம கொடுக்குற மரியாதை அவங்களுக்கு நம்மளுக்கு உள்ள ஆசீர்வாதம் இது நமக்கு கண்டிப்பா இருக்கும். நம்ம பெற்றவங்களோட ஆசீர்வாதம் உள்ள இருக்கிற ஸ்டூடெண்ட்ஸ் திரும்பி சொல்ற அதை இருந்தா மட்டும்தான் லைஃப்ல நம்மளால ஷைன் பண்ண முடியும். இல்லைன்னா ஒன்றும் கிடையாது. பெற்றவங்களோட ஆசீர்வாதம் எப்பவுமே நம்மளுக்கு இருக்கணும். அது இருந்தா மட்டும்தான் நம்மளால எங்க போனாலுமே ஷைன் பண்ண முடியும். சரிங்களா? இது என்னோட ரெக்வெஸ்ட். எப்பவுமே நம்ம பேரண்ட்ஸ் அவங்களோட பிளஸிங்ஸ் எப்பவுமே இருந்துட்டு நீங்க அவங்களோட எவ்வளவு தூரம் தள்ளி இருந்தாலும் எப்படில அங்க இருக்கிறான்னு சொல்லிட்டு உங்களுக்காண்டி அவங்க ப்ரேயர் பண்ணிட்டே இருப்பாங்க. எப்பவுமே அவங்களோட ப்ரேயர் வந்து உங்களோட லைஃப்ல எல்லாமே சக்சஸா மாற்றும். இவங்க எந்த சின்ன ஃபெயிலியர் இருந்தாலுமே அது உங்களுக்கு வந்து ஒரு பெரிய சக்சஸ், ரொம்ப சக்சஸா கொண்டு வந்து சரி. ஏன்னா நான் சொன்னேன்ல, பேசிக்கலி ஃபிஷர்மேன் ஃபேமிலி யூஜி பண்ணேன். அப்புறம் வந்துட்டு நான் யூனிவர்சிட்டி 2012 வந்து ஐ ஜாயின் எம்எஸ்சி யூனிவர்சிட்டி. That time in Crossfield College, location because one of my UG professors he said to me to the university, okay, you have done a wonderful studies in your UG because I got UG rank, okay, you got wonderful studies and wonderful score and everything. It's better you can approach the universities, institutes for higher studies like this. He told because of him only I approached the MS University. That time no interest nothing, purely merit basis. That's a counseling seat, okay, and என்னோட நேம் பார்த்தீங்கன்னா ஓப்பன் காம்படிஷனில் ஃபஸ்ட்டு ஓசிலே ஃபஸ்ட்டு வந்துருச்சு. ஸோ இது நம்மளுக்கு எந்த கோட்டா சீட்டும் கிடையாது. ஸோ ஸ்டடீஸ் ரொம்ப முக்கியம். ஃபஸ்ட்டு பேரண்ட்ஸோட பிளெஸிங்ஸு, ரெண்டாவது உங்களோட ஸ்டடீஸ். இது ரெண்டும் இருந்துச்சுன்னா யாரையும் நம்ம டிபெண்ட் பண்ண வேண்டாம், நம்ம அப்படியே போய்கிட்டே இருக்கலாம். ஸோ அப்படி யூனிவர்சிட்டிக்கு போகும்போது அந்த சார் என்ன சொன்னது, ராணினா காலேஜ்னு ஒரு ஸ்டாஃப் கண்டக்டர் சொல்லுவார், அதுக்கு அடுத்த ஸ்டாஃப் தான் யூனிவர்சிட்டி. ஸோ ராணினா காலேஜ் போகும்போது நீங்கள் ரெடியாக இருந்துக்கோங்க இறங்குறதுக்கு அப்படின்னாரு. ஸோ அப்போ இருந்து மைண்ட் செட் ஆயிடுச்சு, ஓகே ராணினா காலேஜ் எடுத்து யூனிவர்சிட்டி, ராணினா காலேஜ் எடுத்து யூனிவர்சிட்டி அந்த எஸ்எம்எஸ் பஸ்ஸில் ட்ராவல் பண்ணும்போது. ஸோ இது என்னோட ஒன் ஆஃப் தி மெமரிஸ். எஸ் 2021 my PhD got awarded. Then 2022 I got a job in MBJ College of Engineering, Bangalore. That's the only one institution in Karnataka, that's a Tamil minority college. Now all over Karnataka we cannot find any single Tamil minority college, but our college is the only one college, is a Tamil minority college funded by Kannada government. Yes, there Kannada is compulsory, so we learned Kannada, Hindi and all. Apart from that, currently I have 2 scholars, they are doing their coursework. Apart from that, projects are approved by VGC, Karnataka government, and those 2 scholars, they are doing their PhD and doing almost project we generated 20 lakhs. Okay, now we'll go to the talk. My talk is metal. Metal chalcogenerated thin films, a promising avenue for next generation solar cells. Actually, most of the things that I'm BS sir, he was my MSc teacher. He taught me mathematical methods of physics in my first semester, EMT in my second semester, mathematical methods of 2 in my mathematical methods in my third semester. Again, he took material characterization in my fourth semester. So, and during my MPhil SAR and research methodology paper in my first semester, and in the second semester, at the end of my Viva was examination, he was the external examiner for my Viva. And for my PhD was the examination. That time they conducted through online mode. Sir was the observer. So, sir was nervous. Sir yes. This is my campus. It is located in Whitefield, Bangalore. These are entrance, college entrance, and the downside image, that left side it is campus. Previous side. Yeah, and we have wonderful lawn in our campus. Yes. Nice. See, I'm not going to teach all those things. Okay, in the first origin of solar cells, everyone is saying that solar cell technology gone from silicon. No, actually, scientists they observed the photoelectric effect or the photovoltaic effect from selenium wafers. Selenium is one of the important materials in our solar cells. So selenium belongs to which group? In the periodic table. Selenium. See, we have S block, we go P block, in the middle we go D block, and down we go F block, right? So we have 4 different blocks, S, P, D, and F. Okay. Selenium belongs to which block and which group? Selenium. Okay, leave it. It belongs to P block. Okay. In P block, we have many interesting elements, right? That last column, it consists of all the noble gases, right? And in the P block, we have semiconducting elemental materials. In the P block, we have chalcogens. In the P block, we have halogens. All the research works are basically from these halogens, these chalcogens, especially photovoltaics. B.S. Sundaranand sir explained very well that photoelectric cells, photovoltaic cells. Actually, most of the contents are already explained, so I'm not going to tell you all that in detail. So, first, the solar cell. The basic of the solar cell is nothing but photoelectric effect. What do you mean by photoelectric effect? Ejection of electron from the metal surface, right? The same thing we are doing in the solar cells or photovoltaic cells. Okay, so in solar cell or in photovoltaic cells, what usually we are doing? We are separating the charges. We are storing the electrons and we are storing the holes. The same thing. Actually, the photoelectric effect, that was the basic for all the photovoltaic photoelectrochemical cell process. So in 1883. It is one of the remarkable years for the photovoltaic people. In 1883, Charles, an American inventor, he described the first solar cell made from selenium wafers. Yeah. Still, people are using silicon wafers. Silicon wafers or silicon solar cells. They achieve the remarkable efficiencies. Okay, none of the materials in the periodic table, they are unable to reach the maximum. They are unable to reach the efficiency up to the silicon. But the thing is, silicon, the material itself has silicon. It is a material. We can categorize the silicon into 2 types. One is amorphous silicon, another one is crystalline silicon. Again, crystalline silicon we can categorize into 2 types. One is polycrystalline, another one is monocrystalline. Monocrystalline silicon, it has an efficiency up to 23% according to literatures. But so far we accept only 19%. See, for monocrystalline crystalline silicon, according to literatures, they are achieving up to 20%, but people they achieve up to 13 to 17%. Whereas amorphous silicon, they achieve almost 8 to 13%. The thing is, silicon wafers are they are high in cost. Okay, so what the scientists or what people decided. They wanted to replace the silicon wafers, okay, in order to save some money or in order to make some efficient materials. Basically, silicon is a semiconducting material. Through silicons, they achieve the maximum efficiencies. See, solar cells like organic photovoltaics, they achieve almost 23% of efficiencies, and they consist of some organic materials. Apart from that, P3HT, polyethylene. Then they have some lead material. So it is not good for our human surrounding. So still researchers are going in the organic photovoltaics also. But the thing is, organic photovoltaics or perovskite solar cells, they almost achieve the efficiency of the silicon level. Yeah, go to the next slide. First, selenium wafers, they observed or they described photovoltaic nature. Then in 1954, the photovoltaic technology born US lab. Then again, 1958, first PN junction solar cells were made in American laboratories. Next.
ஆமாம் அவங்களுக்கு
Yes. The first part, sustainable energy. எதனால நம்ம sustainable energy தேடுறோம்? What are the importances or what are the key points to search or for the search of sustainable energies? Next. First one is global energy demand and climate change. See, the population day by day it is increasing. The population day by day it is increasing. See, in Tamil Nadu we are paying some 2 rupees per unit. How much we are paying per unit? Per unit, EV. Okay. But in Karnataka we are paying almost 11 rupees per unit. 11 rupees per unit we are paying. But the thing is, there every 20 days once I will get a bill, EV bill. Okay. So, okay. There in our apartment we are using solar water heaters. Most of the items are made by solar materials. See, if I'm using continuously geyser or anything, because their climate also very chill, so we cannot use normal water for our regular uses. So obviously we are depending on hot water. Okay, so if I use that electricity for heating the water, say I am using, my family members they are using, my apartment members they are using, then my entire layout members they are using, and the entire Bangalore is using. Then you think about the usage of electricity. Think about the usage of electricity. Then think about the source. Do we have that much source? Do we have? No. Right? So, yeah, this is one of the major reasons. First one is the population. Next. Then limitation of current solar cell technologies, especially silicon. Silicon solar cell, they are cost effective. Their cost is more. Next. Yeah, but theoretically they achieved almost 29%, but they got the efficiency around 15 to 22%. And their material manufacturing cost also high. Then, yeah. Then this is one of the important needs to search for other materials. Infant cost previous. Infant cost effective and high efficiency alternatives to the silicon based solar materials. See, and nowadays research is going on in metal chalcogenetic thin films. People are achieving with the help of CZTS, copper zinc tin sulfide, CAGS, copper indium gallium sulfide or copper indium gallium selenide. The thing is, copper indium gallium selenide, it showed very good efficiency. And it's a stable material, but the thing is, the manufacturing process is tedious. So it has 2 advantages, meanwhile it has 1 disadvantage. Okay, next. Thin film properties and applications. Because we are using second generation solar cells. All the solar panels are second generation solar panels. So we can categorize solar cells into 3 different generations. First generation solar cell, second generation and third generation. First generation solar cell only deals with silicon wafers. Whereas the second generation solar cells, they have thin films. Thin film solar cells are coming under second generation solar cells. And we have the last one, third generation solar cell. The third generation solar cell, under this we have QDACC. Then we have dye-sensitized solar cells. We have organic photovoltaics, that means organic solar cells, and we have organic perovskite solar cells. They are coming under third generation solar cell, but I am not going to explain about any first generation or third generation because my research is based on the second generation solar cells. Second generation solar cell building blocks are thin films. So without thin films, we cannot fabricate or we cannot produce any kind of solar cells. Say thin film, the word itself is having the definition. So their thickness should be in the order of 10 to 100 nanometer. And yeah, we can use the thin film materials or thin films for anti-reflective coating, anti-corrosive coatings and decorative coatings. Thin films, we are using temperature controller. Thin films as a temperature controller. Next. For all the microelectronic devices, for photoconductors. Next. For recording devices, for IR detectors. Then for magnetic and gas sensors. Finally, then solar cells. The major application of the thin films are the solar cell. So with the help of these thin films, we can produce or we can fabricate our own solar module. With the help of modules, we can fabricate our own solar panel. With the help of panel, we can fabricate our own solar device. Then these are the general about the solar cell. Solar cell is also known as a photovoltaic cell. Okay, for solar cell, which have some metals, what to say, some ITO or FTO, substrate transparent containing oxide. Over to that, we should coat treated material. Over that, we should coat any intrinsic layer or any tissue materials. Over that, we should coat our N-type material. Again, over to that, we can coat some other anti-reflective coating. Then metal contact for segregating or for separating the charges. Next. Yeah. See, this is an important graph. This graph is derived from some devices. Okay. Then you see where x-axis is representing voltage and y-axis is representing current in terms of ampere. See, this point is representing your open circuit potential or VOC, that denotes your open circuit voltage when your current value is 0. When your current is 0, the maximum voltage is referred to as open circuit potential. Meanwhile, when your potential or when your voltage is 0, applied voltage is 0, you will be achieving the current. That current is known as short circuit current. And this square area is the important thing, because in this square area only, we can call it as an active area. There we can calculate the Imax Vmax value. With the help of Imax Vmax value, we can calculate fill factor. See, we can define the efficiency of the solar cell with the help of fill factor. If you are getting good fill factor, your efficiency will be more. If you are unable to achieve that much of good amount of fill factor, your efficiency will be lower. So, before starting any work, you should do the proper literature survey or proper literature review. With the help of literature review, you can synthesize your samples. With the help of your sample, you can prepare your module. With the help of the module, you can go for the photovoltaic or IV studies. Then from the studies, you can plot your graph. Then you can give an interpretation. For this graph is applicable for both photovoltaic and photoelectrochemical cells. Okay, in both the cells, in photovoltaic and photoelectrochemical studies, we are studying the efficiency with the help of the fill factor. In order to calculate fill factor, you should know about the maximum voltage and maximum current. That is known as Imax Vmax. You see this graph. This point is noting your maximum voltage, and this point is showing your maximum current. So this point is known as Imax Vmax point. Some formula are there. With the help of those formula, you can calculate the fill factor. With the help of the fill factor, you can calculate the efficiency. And what is a solar cell? It is a device that is used to convert the sunlight into electrical energy. Not convert, it is used to store the electrical energy. Next. See, there are three basic attributes in solar cells. First, you should pass the light, and your material should have the capability of absorbing the light. Then it should generate electron hole pair. Then it should separate the extraction of those carriers to the external circuit. So three basic things are there. First one is absorption of light. Second one is separation of charge carriers. Then third one is storing the charges. And these three things are the important things in the photovoltaics. We have conduction band, we have valence band, and the distance between the separation distance between conduction band to valence band is known as the energy gap, right? If the energy of the photon, if the energy of the incident photon is lesser than is greater than if the energy of the photon, if it is greater than the band gap, okay, what will happen? It will produce heat. It will produce heat. So you won't get any proper device performance. Then the second thing is, if the photon energy is lesser than the band gap, okay, then what will happen? the photon will pass through the material. Then the third one is the energy of the photon if it is equal to the energy gap, this one. So energy of the photon, energy of the incident photon is equal to the energy gap. Then what will happen? It will create the electron hole pair. So it is the required thing. So this condition is the required thing. We have three different cases. First one is energy of the photon is lesser than the energy gap. Second one is energy of the photon is equal to energy gap. Third one is energy of the photon is greater than energy gap. But the thing is, in that case, energy of the photon should be equal to energy gap. Then it will be able to create the electron hole pair. Yeah, in the graph I explained, we have short circuit current, we have open circuit voltage, we have fill factor, next, and we have efficiency. If you know all the value, you can calculate your efficiency with the help of the given formula from your literature review. Next. Yes, various types of solar cells. Next. Solar cell we can categorize into three types. First one is silicon semiconductor, compound semiconductor, and organic semiconductor. Again, silicon semiconductor we can categorize into two types. First one is crystalline, then second one is non-crystalline. Silicon, again the crystalline is categorized into two types. First one is single crystalline, another one is polycrystalline. The efficiency is also reported. And our interest is the compound semiconductors. They are nothing but the thin film solar cells, second generation solar cells. Next. Next. Yes. Now I am going to talk about the second generation solar cells. Next. Yes. Wait. See. This is schematic diagram which is representing the second generation thin film solar cell. There we have the substrate. The bottom part is the substrate. Then over to that we are coating the N layer. Then this is your intrinsic layer. Again, then we are coating the P layer. Over to that we are coating some transparent conducting oxide layers. We can use either zinc oxide or tin oxide. Then they are known as anti-reflective coatings because these anti-reflective coatings they are playing a vital role. We have N-type material, we have P-type material. Apart from that, we have two more interesting material. One is the TCO, that is anti-reflective coating. Second one is the buffer material or buffer layers. Actually, buffer layers, they are also important materials in the solar cell because they used to enhance the transportation of electron and holes. Okay, it will stop the electron and holes to recombine. If recombine takes place here, we will not get the efficiency. If an electron and hole, they are recombining with each other, means we will be getting the light again. We will not get any electricity. So, we should stop the electron hole recombination. Okay, in this entire solar cell or in the photovoltaics, we should stop the recombination of electron hole. We should separate or we should segregate electrons one side and holes in the other side. These buffer layers are the important materials to stop the recombination of electron hole pairs. Yes, and what are the advantages of the metal chalcogenate thin films? See, if you are preparing any solar cells with the help of sulfur or selenium or tellurium, those solar cells will be called as chalcogenate thin film based solar cells because the sulfur, selenium and tellurium, they are known as chalcogen materials. Okay. And we have numerous works in tellurium, especially cadmium telluride. It is one of the well-known material, but the toxicity of cadmium, people are nowadays they are not using this cadmium telluride as a solar cell material. But we are getting in our day-to-day life, we are getting more number of articles from this sulfur and selenium based chalcogens because we can view the band gap of the chalcogen materials. So band gap is the important parameter. Apart from the structure, band gap is the important parameter in the solar cell field. Okay, your band gap only decides that your material is applicable for solar cell application or not. See, we are studying spectroscopy in our MSc or PhD. Where are we going to apply? What are we studying in our MSc or PhD? In your research only you can apply, right? There we are studying m is equal to 1, sorry, m is equal to 2, m is equal to 3 by 2, m is equal to half, some direct allowed, indirect allowed, some forbidden. You should observe the optical absorption nature of your material. If your material is having the capability of absorbing the light from the range of 4,000 to 7,000 angstrom, right? So your material should have the ability of capturing the photons or absorbing the photons from the sun from the range of 400 to 700 nanometer. If your material is having the capability of absorbing the photon from 200 to 400 means we cannot use those kind of materials for the visible region because 200 to 400 refers to UV region. See, if it is above 700 nanometer or above 7000 angstrom, that is also not applicable for your visible region. That is only applicable for the IR. So the optimized region is from 400 to 700 nanometer. So almost all the chalcogen materials, especially if you are combining a metal with a chalcogen, that will be known as metal chalcogenate. So yeah, we can formulate either binary chalcogenate or ternary metal chalcogenate or quaternary metal chalcogenate with the help of some metals from D block elements and some non-metals or some semiconducting metals from P block, again the chalcogen from P block. Okay. You see the well-known materials from the P blocks are bismuth group materials, aluminum, bismuth, aluminum, antimony, those materials. Apart from that, sulfur, selenium, sulfur, selenium, tellurium, and we have copper, gold, zinc, those kind of materials. Now research is going with the materials of strontium, with the materials of chromium. Researchers are still doing, and but they are unable to achieve the efficiency because those materials are unable to capture the photons from the sunlight in the region of 400 to 700 nanometer. And one more thing, if your optical absorption is good, then you should calculate the absorption coefficient, that is alpha. Alpha is equal to 1 by the log of 1 by t. Some formula is there to calculate your alpha value. That alpha only decides the nature of your band gap, the nature of the band gap of your material. If the value is more than 10 power 4 centimeter inverse, if your absorption coefficient value is more than 10 power 4 centimeter inverse, directly you can say that our material belong to direct band gap material, because in the entire solar cell family, we are the entire solar cell research, we are focusing only the direct allowed band gap material. So what is the criteria? How to confirm that whether my material is direct band gap material or not? Your alpha value decides your alpha value. That alpha is nothing but absorption coefficient. That absorption coefficient decides the nature of the band gap. The absorption coefficient is more than 10 power 4 centimeter inverse. So then we can confirm that our material belong to direct band gap material. So we can, with the help of spectroscopy, we can substitute the proper N value. Then we can calculate the band gap. Yes. Then these metal chalcogenate films. They are low-cost material and easily we can prepare. We can synthesize these kind of metal chalcogenate films. In our laboratory we are preparing, and if you have, if you got any time with any companies, you can extend your work from laboratory to industry. See, I am basically from physics field, but now I am guiding people from electronics and communication, and they have their tie with industries. Bell and my people are doing research in HAL, NAL, National Aerospace Limited, Bangalore. There is a Central Government Institute. And one of my students, he got his internship at ISRO Bangalore. He is doing his internship there. See, you may think that, what is there in physics? We are studying the concept. No. Physics, see, you go anywhere, go with your friends and they will belong to physics. For an example, okay, you go anywhere, you will get the proper recognition than other people. See, in our campus, almost we have more than 6,000 students. All the 6,000 students, they know about the physics faculties, but they don't know about their English faculties and other department faculties. They don't want to reveal their names. Because physics, without physics, engineering is nothing. Without engineering, technology is nothing. Right? Without technology, so the basic is physics. You try to understand the concepts, each and everything of physics. Okay, update yourself by day to day. Okay, instead of posting reels, chats and Instagram, please try to learn something. Many YouTube channels are there, many Insta channels are there about physics, right? Try to spend your time daily half an hour, daily 45 minutes, it is enough. Okay, then you'll be getting the proper recognition in your future. Because in Tamil Nadu, most of my friends are working here, and they are handling only first year subjects. What they are telling, physics, that's the first year subject. But apart from Tamil Nadu, people are giving more importance to physics people and maths people. See, we are the faculties, only one department. We are handling SEM 1 to SEM 8, and we are handling MTech papers. Since I am an MSc student, but I am handling MTech paper. So we are studying electromagnetic theory. Without electromagnetic theory, EC is nothing. Electronics and communication, that is nothing. Without electromagnetic theory, EEE, it is nothing. We are studying Norton's theorem, we are studying Thevenin's theorem in electronics. Without those theorems, network analysis is nothing. What people are doing in, power stations. Most of the people are from EEE department, not EEE people. Without knowing physics, they cannot study their EEE subjects, and they cannot apply anything without knowing physics. So physics is the fundamental, physics is the basic. Without physics, nothing is there in the universe, right? So, last month, how many of you watched the landing of Sunita Williams? How many of you live watched all those things? No. So basically, she is from Sunita Williams. Basically, she is from which background? No, not from her origin. From her studies, I am asking you. Basically, she is from aeronautical engineering or aerospace engineering or mathematics or physics or chemistry. Physics. How many of you agree that she is from physics? Guys, update yourself. It is very difficult. It is very, very difficult. I am not demoting people. Okay, please try to update yourself. Okay. So people are telling, see, I studied MSc Physics, but I am unable to get any good jobs. Jobs are there, opportunities are there, but we are not ready to get the opportunities. We are simply blaming from our side, right? Say, I am not getting, I am not getting, I am not getting. There are differences between I am not getting and I am unable to get. How many of you agree? Differences are there between I am not getting, I am not getting, I am unable to get. If you know the answer, please, my wishes. If you don't know, you please think why I am not getting. Why people are getting, why I am not getting. Opportunities are there. So during my interview, almost 23, 24 people came at a time. They recruited only one, that was me. See, almost 23 to 24, they are experienced. Right? See, what all we learned from our professors. See, Sundarangan sir, we cannot describe it. Because he taught all those things with live examples and all. Even he trained us for our GATE exams. In the year of 2012, 2013, we applied for our GATE exams. Still, he is motivating students. These students still he is motivating students. See, you should have that thirst. Then only you can grab all those things. Try to update yourself. Next. I told that copper indium gallium sulfide, CIGS, that the efficiency is good and it's an iron bandgap material, but the thing is, the fabrication method is complex. You cannot easily synthesize copper indium gallium sulfide in our laboratory. The second thing, that is your cadmium telluride. Cadmium telluride, it achieved high efficiency almost, which is similar to silicon wafers. But the thing is, the cadmium is toxic, more toxic. So we cannot use that cadmium or lead. Even lead sulfate and lead sulfate also achieve very good efficiency. But nowadays people are not using those lead things because of the toxicity nature of cadmium and lead. Then tin sulfate. Tin is a depth abundant material, but thing is it cannot achieve the better efficiency. And the fourth one is CZTs, copper zinc tin sulfate, copper zinc tin selenate. Then nowadays people are using barium. People are using bismuth in this. And those kind of solar cells are known as tandem solar cells. Tandem solar cells zero n number of layers. And the banding of each and every material is the important thing in tandem solar cells. In the solar cell we have glass material. Here we are using some molybdenum coated glass material. Over to that silver barium tin selenide, that is the P-type material. Over to that we are putting some buffer, then intrinsic layer, then metal contact, then front contact we are using. You see this buffer layer we can use cadmium sulfate, we can use barium sulfate, we can use strontium sulfate, we can use calcium sulfate, and we can use magnesium sulfate. Actually, these materials are new materials in photovoltaics. This magnesium sulfate, this calcium sulfate, and this strontium sulfate. Previously, people they used this strontium titanate. They use those materials for memory storage devices in readers or also magnetic applications. They are coming in the perovskite category. Strontium titanate, barium titanate, bismuth titanate. But the thing is, nowadays people are using those kind of materials, these perovskite materials, in the solar cell field. And these buffer layers they use to improve the interface quality, and they are used to protect the layers from the degradation, and it is used to stop the electron hole recombination. Almost first generation solar cells, they are silicon based solar cells, the cost is high, but their efficiency is more. That's a drawback. That's a drawback. And the second thing is metal chalcogenide thin films. In the metal chalcogenide thin films, we have all the D block materials. With the help of D block materials, we can produce our own module. That is our metal chalcogenide thin films. The thing is, in metal chalcogenide thin films, we have lead, we have cadmium, right? We have tellurium, and if you add some more material, you may get some good efficiency, but the thing is, there is stability, there is a question mark. We cannot preserve or we cannot use our material for a longer period. So stability is an important thing. So people now they are using perovskite or tandem solar cells with the help of chalcogens. Perovskites are nothing but AbO3, right? That O3, if you have AbO3 composition, you can say those materials are perovskite materials. Now people are using barium titanate, bismuth titanate, strontium titanate, and then tandem solar cells. If you have n number of stacks, or the P, N, I, P, N, I, those kind of materials are known as tandem solar cells. Yes. Then the second thing is quantum dot sensitized chalcogenide solar cells. See, we have some similarities between DSCs and quantum sensitized solar cells. In dye sensitized solar cells, we are using two electrodes, two I2 substrates, and one is your coated, film coated. In between two electrodes, we are putting the dye. That process is known as dye sensitized solar cells. In the case of quantum dot solar cells, instead of dye, we are putting quantum dots. We are putting quantum dots, and these quantum dots, it attracts more researchers. People are doing, but the thing is, the cost effect is more. It is not easy to form, or it is not easy to prepare the quantum dot solar cells. It is a tedious process to get to achieve the quantum dot first. What is quantum dots? If the materials grains is crystallizes of the material, if it is lesser than 10 nanometers. Okay, if you are characterizing your quantum dot, you won't get any defined peaks, because you have general equation that d is equal to k lambda divided by delta cos theta. Right? Your crystalline size is what? Your crystalline size is very small, then you don't get any sharp peaks. So that process is there. then people are doing some theoretical researches. See, we studied the silicon solar cells, we studied the gallium CAG solar cells, we studied the CSA solar cells. In the laboratory, we can prepare all those things. But where to confirm whether this compound is formed or that compound is formed, and people are using JCPDS. Most of the JCPDS are generated through the computational research. In order to do some computational research, you should know some basic programs. For example, Python program. That is the important thing. Or Fortran program. So try to enhance the programming knowledge, coding knowledge. You should. If you know the Python program, or if you know how to write a program in C++, or if you know how to write a programming program, you can easily get n number of. Then novel abundant materials. Anyone can do that novel material. Anyone can invent novel material. But the thing is, we should define my material is novel. Why it is novel? For that, we should update the self-proclaimed material is a novel. And third one is organic photovoltaics. The thing is, the organic photovoltaics, the stability is not that much good. That is a first drawback. But the efficiency is good. We cannot sustain those organic photovoltaics for more than 20 days. It will degrade. Stability of the solar cell, important thing. Then battery of the solar cell, important thing. Then cost effective is the important thing. In organic photovoltaics, battery aspect it is good, and the cost effective it is good. The stability wise it is not good. So when you know the perfect I immediately if you want, you can, if you have any queries, you can mail.
Thank you, sir, for your remarkably thought-provoking presentation, and it offered a unique perspective on this topic. Your presentation brings a wealth of knowledge, experience, and passion to the table.
May I now call upon Dr. Pravina Ma'am to extend a formal vote of thanks for this session.
Good afternoon, everyone. Good afternoon, everyone. It's my privilege and honor to propose the vote of thanks for our honorable speaker, Dr. T. Daniel, for sharing the valuable insights about chalcogenide
Solar cells. Your words have truly enlightened and inspired us. The depth of our knowledge and the clarity with which you presented it was remarkable. Once again, thank you, sir.
Now we delve into our next session, oral presentation. It is important to note the time constraint. For oral presentation, each presenter has a strict limit of 5 minutes, 3 minutes for your presentation and 2 minutes for question and answer session. The oral presentation will be chaired by our resource person, Dr. T. Daniel.
Good afternoon, sir, and everyone. It's my pleasure to welcome Dr. T. Daniel, who is guiding today's oral session. Yes. Okay.
Good afternoon, everyone present here. Before we begin, here are a few important guidelines to ensure a smooth and productive session. Each presenter will be given 3 minutes to present, followed by 2 minutes for the guest. Please be mindful of the time limit. We request all presenters to maintain a professional and respectful tone during their talks. Let's ensure an engaging and insightful session for everyone. I invite our first presenter, Ms. Gauri, a research scholar at Sarataka College.
Good afternoon, everyone. I am Gauri, doing research under the guidance of Dr. Joy Vijila ma'am. My research topic is synthesis and characterization of molybdenum nickel selenide transition metals chalcogenide nanomaterials by solvothermal method for supercapacitor applications. Next slide. These are the introductions. Okay, sir. Next, results and discussion. Okay, the first, the prepared nanoparticle is carried out for characterization. From the XPS analysis, the results were found. The XPS analysis is used to determine the elements present in the nanomaterial, and it is used to identify the chemical state of the nanomaterials. And that figure shows the XPS spectra of the molybdenum nickel selenide nanoparticle. Next slide. These slides shows the deconvoluted graphs of molybdenum, nickel, and the next slide. And this is the deconvoluted spectra of selenium present in the molybdenum nickel selenide nanomaterial. And this shows the tabular column shows the binding energy of the materials present in the nanomaterial molybdenum nickel selenide, and the oxidation state of molybdenum nickel and selenide were identified, and it is found that the nanomaterial formed is a novel material, a new phase molybdenum nickel selenide is identified from XPS analysis. And the next analysis carried out is the XRD analysis. From the XRD analysis, it is confirmed that the narrow peak shows the crystalline nature of the material, and the average crystallite size is calculated using T/Scarab formula, and the value, next slide, and the value is found to be 44 nanometer. The angles, the 2 theta angles observed for the molybdenum selenide nanomaterials were observed, in which 1 or 2 angles match with the binary code of JCPS. The remaining angles doesn't match with the binary selenide. From this, it is confirmed that the formation of the nanomaterial is of new phase, which is again confirmed from the peak shift. Okay, previous slide, please. You can see the peak shift of the molybdenum nickel selenide, which is confirmed from the molybdenum selenide material, which I prepared as a basic material for my research work. And from the peak shift, it is confirmed that the novel phase material is formed. From the XPS analysis, we confirm the novel phase formation, which is again supported by the XRD result. The next characterization result is the UV visible analysis, and the transmittance study of the molybdenum nickel selenide material is shown. In the UV visible region, the transmittance found to be very small, and it is found that the absorption is very strong in that region, and in the visible and in the infrared region, the transmittance increases, and these materials shows transparency in that region. Next slide. And from UV visible analysis, the band gap of molybdenum nickel selenide nanomaterial is calculated by tau plot, and the value is found to be 1.41 volt. And conclusion. The molybdenum nickel selenide nanomaterial is prepared by solvothermal method, and from the XPS analysis, the oxidation states of the elements present in molybdenum nickel selenide nanomaterials were confirmed, and the new phase formation is also confirmed from the XPS analysis. And from visible analysis, from XRD analysis, the crystallite size, and also the peak shift confirmed the novel phase formation. The UV visible analysis shows strong absorption in the visible region and translucency in the visible and infrared region. The band gap value is calculated from UV visible analysis. Thank you. Application of supercapacitor for energy storage I am using. Yes, sir. I have prepared the electrode, and the electrode is carried the analysis like electrochemical performance I have measured. For CD is carried out. Impedance study is also found, and TC, charge discharge study I have carried out, sir. Yes, sir. Stability, I want to calculate, sir. The basic studies, I have found specific capacitance value, energy density and power density I have calculated till now. The stability I want to calculate.
Compare your results with earlier reports. Which one is better, earlier or yours?
When we incorporate the nanomaterials like nickel, manganese, the material found to have high energy density, power density when compared with molybdenum selenide nanomaterial.
This session is open. Any doubts you can ask?
I thank any doubt and clarification you can ask. Audience? Nobody?
I thank Daisy ma'am. Thanks, sir.
Yes, and one more thing, we should acknowledge the guide because she is the first scientist, the first researcher who published the paper in copper molybdenum antimony sulfate films, other solar cell material.
Thank you all.
Thank you, Ms. Gauri, for a wonderful presentation. Now I would like to invite our next presenter, Sujati S.
Good afternoon to all. I am Sujati, research scholar from Rani Amma Government College for Women, Delhi. I am doing research under the guidance of Dr. J. Daisy McLean. The title of my presentation is Electronic Structure, Vibration Spectral Analysis and Molecular Docking of 5-bromo-2-thiazine carboxylic acid, a density functional theory. These are the studies I am going to discuss today.
Get after the results.
The aim of the present work is to describe the structural parameters, vibration spectral analysis, and electronic properties and biological activity of BTC. Discussion. The first one is molecular geometry. The structural parameters of BTC have been calculated by DFT method and are compared with the experimental data of the thiazine molecule. So all the bond and values of BTC agrees well with the bond and values of the parent thiazine molecule, but the bond and values of BTC show some deviations from the thiazine molecule. These deviations are mainly due to the electron withdrawing substituent at the second and fifth position of the thiazine ring. Vibrational analysis. Vibrational analysis is used to identify the functional group present in the molecule. Here, the sequence symmetric stretching vibrations are expected in the range of 3100 to 3000 centimeter inverse. The experimental and theoretical values of BTC agrees well with the expected value. The C double bond O stretching vibrations are expected in the range of 1800 to 1690 centimeter inverse. The experimental and theoretical values also agrees with the expected value. But the CMU symmetric stretching vibrations are expected in the range of 650 to 450 centimeter inverse. But our experimental and theoretical value shows some deviation from the expected value. This redshift is mainly due to the resonance effect of the thiazine ring. HOMO-LUMO. The highest occupied molecular orbital HOMO and the lowest unoccupied molecular orbital LUMO plays a prominent role in determining the chemical reactivity and kinetic stability of the molecule. Here, the HOMO is main. Here, in our compound, the HOMO is mainly localized on ring CC bond
and oxygen atom and bromine atom, and the loop one is mainly localized on the entire molecule. The energy gap value is 4.872 electron volt. This smaller energy gap value indicates low kinetic stability, high chemical reactivity, and better biological activity. Molecular electrostatic potential. The molecular electrostatic potential is useful to determine the reactive sites of the molecule. Here, the red color indicates negative electrostatic potential favorable for electrophilic attack, and the blue color indicates positive electrostatic potential favorable for nucleophilic attack. In our compound, the reddish yellow color is around oxygen atom, which indicates electrophilic sites of our compound, and the blue color is around hydrogen atom, which indicates nucleophilic sites of our compound. Molecular docking. In order to get an in-depth knowledge about the interactions of ligand with protein and to check its biological activity, molecular docking approach is used. Here, the BTC is obtained from compound BTC is obtained from the optimal structure, and the protein 1NQ, which is responsible for the arrhythmic stimulus, is obtained from RCSB protein data bank. The BTC shows significant anti-arrhythmic activity with a binding energy of -6.63 kcal per mole. And the hydrogen bonding interaction between the carboxyl group of BTC and the 1NQ active site residue indicates that carboxyl group acts as anti-arrhythmic active site of BTC. Conclusion. The entire quantum chemical computation have been performed using GFT method. The FTIR and FT-Raman analysis have been performed to determine the vibrational modes of BTC, and the HOMO-LUMA and MESP analysis have been performed. And finally, the docking results predicts that our compound shows good anti-arrhythmic activity. Thank you.
Question session is open. If you have any doubt, you can ask without fear. Anybody asking question? No, sir.
மேலையாமா 7 ஆமா
Please keep the
Thank you, Ms. Sujami, for your wonderful presentation. Next, I call upon our next presenter, Jan Gnanapolan.
Good afternoon, everyone. Good afternoon, sir. I am Jane, research scholar under the guidance of Dr. Joy Trivulji. First one is the XPS analysis. From this study, we can confirm the oxidation state and chemical composition of the material. This is the deconvoluted peak of zinc. The oxidation state of zinc is 2+, that is corresponding to the binding energy of 1022.1 electron volt and 1045.1 electron volt. Next, this is the deconvoluted graph of antimony. The oxidation state of antimony is Sp3+, corresponding to the binding energy of 531.4 electron volt and 539.7 electron volt. And this is the graph of selenium, deconvoluted peak of selenium. The oxidation state of selenium is 2-, corresponding to the binding energy of 54.9 electron volt and 55.5 electron volt. Here we can confirm the phase formation, that is Zn is Sp2 Se4. Next.
from XRD analysis, here we can confirm the angles that are matches with both orthorhombic sp2 se3 phase and hexagonal Z and SE phase. This is the primary peak shift. 2 theta is equal to 30.17 degree is shifted to a lower angle. That is 2 theta is equal to 30.15 degree. Here we can confirm the incorporation of Zn atom into the sp2 se3 lattice. The crystalline size was 58 nanometer, which we can determine by de-Besker formula. From UV analysis, we can see the higher absorption in the UV and visible region, but it slightly decreases in the at the visible region, but it is almost constant. And this is the band gap energy of Zn sp2 se4, that is 1.76 electron volt, which is suitable for photovoltaic devices. Next conclusion, here we can conclude the Zn sp2 se4 thin film were synthesized using chemical bulk deposition method using complexing agent as TEA. In XPS analysis, we can confirm the oxidation state and chemical composition. From XRD analysis, we can confirm the peak shift that confirm the novel ternary Zn sp2 se4 thin film. And from UV analysis, we can find band gap that is 1.76 electron volt and higher absorption is seen in the UV visible and nearly IR regions. Thank you.
So you incorporate the zinc into
Anti-concealment.
anti-concealment lattice, right? Which process?
Chemical bulk deposition. Okay.
Do you have any XRD pattern? Anti-concealment, would it add any anti-concealment pattern?
Actually, I have I first base material on the
Because you mentioned the peak shift.
yeah. So, scholar, it's a good opportunity to clarify any doubt regarding your research area. Anybody asking? No colleagues.
Thank you, Jen, for your wonderful presentation. Next, I would like to call upon our next presenter, Andrew M. Apaji.
Good afternoon, everyone. I am Kaparati, during PhD in Ranina Government College under the guidance of Dr. B. Selvam sir. My topic is giant dipole resonance and shape transition in samarium nucleus. Introduction. The study of the nucleus shape is a very interesting topic of the nuclear physics. Many methods to study of the nucleus shapes we have used in the giant dipole resonance are used to study the shape of the nucleus under the extreme condition of spin and temperature. Purpose of this work is the study of the nucleus shape of the samarium 144 nucleus. Giant resonance. Electric field E is pushed into the protons are upward direction and neutrons into the downward direction. Then the nucleus is get the excited state. This is called a giant resonance. Next slide. Giant dipole resonance. Giant dipole resonance is the one of the type of the giant resonance. It is the tools to study the shape of the nucleus. Absorption or emission of the photons, the boson into the nucleus when the electric field E is pushed into the proton and neutron into the opposite direction. When the nucleus gets the excited state and the nucleus is to create the dipole moment are created. This is called a giant dipole resonance. When the spin is increases, when the nucleus get the various shape transition into the nucleus, when the giant dipole resonance has the spherical nucleus, it is the one single peak Lorentz line. and the nucleus is deformed, we get the two Lorentz peaks. The higher peak is higher, the lower peak is lower, the nucleus at the oblate shape, and the nucleus is the prolate shape. The lower peak is higher, the higher peak is lower. The nucleus is triaxial shape, the peak has the three Lorentz curves. Next slide. Methodology, the giant dipole resonance. Giant dipole resonance is the excited state, so the very interesting evaluation signature of the same transition. To detect the shape is theoretically we have used the GDR cross sections for the as a function of spin, and the calculation value we are used in the Crank-Nielsen-Sutensky method as a function of spin. We have used in the deformation parameters gamma value is obtained to 180 to 120 degree, and the beta value obtains to 0.0 to 1.2 in step of 0.1, and the spin value up to 10 H cross to 16 H cross. The samarium nucleus was 10 H cross. We have the nucleus is spherical. We increasing the spin. The samarium 144 nucleus are no changes in the shape, so that the 16 H cross, the nucleus has the spherical shape. We have plotted in the graph. We have plotted in the graph, and this one is the Corelder graph too. The nucleus is spherical. Thank you. In this photon construction program, we have used the energy value, the information parameter gamma, beta, and the spin values are.
So how do you got the information?
Sorry, is there a period of
So you are taking all the values.
photon construction
You are not performing any.
software use. Photon construction program. Thank you.
Thank you, Dr. Rati, for a wonderful presentation. Next, I invite our next presenter, Afrin Nigar.
Good morning to everyone. I'm Afrin Nihar as a scholar. Here I have synthesized my mixed metal chalcogenate by using solvothermal method. Here my result and discussion XPS analysis. Figure 1 represents the XPS survey spectra which illustrate the existence of titanium, manganese, selenium, carbon and oxygen element. The chemical state of the titanium manganese selenide are examined using XPS analysis. Figure 2 represents the Mn2p deconvoluted peak of Ti Mn2Ac nanoparticles. So here Mn2p core level spectrum with a binding energy of 641 and 653, which assigned to its oxidation state of Mn2p 3/2 and Mn2p 1/2, and the splitting of energy difference. Between these two peaks is 11.8 electron volt. From these, it's confirm the existence of manganese in Mn3 plus state. And then next, this figure 3 represents the Se3D deconvoluted peak of Ti Mn2 Ac5 nanoparticle. It belongs to its oxidation state of Se3D 5/2 and Se3D 3/2 with respect to its binding energy. And then figure 4 represents the Ti 2p deconvoluted peaks of Ti Mn2 Ac5 nanoparticles. It has its oxidation state of Ti 2p 3/2 and Ti 2p 1/2. Hence, it confirms the existence of titanium in 4 plus state. Hence, from the XPS analysis, the phase of the titanium manganese selenide is found to be Ti Mn2 Sc5 nanoparticle. And then furthermore, the variation of the oxidation state is considered as an essential factor to elevate and describing the electrochemical performance, which might lead to charge storage mechanism for energy storage devices. And then XRD analysis, figure 5 represents the XRD pattern of TiMm2 Se5 nanoparticle. So if the observed diffraction peak is well matched with the binary selenites of cubic MnSe and monoclinic TiSe phase, then here figure 6 shows the peak shift in Rami MnSe and TiMnSe2. The broadening in the primary peak width is due to the lattice strain. This strain is arises due to the ionic radius, mismatching of ionic radius, that is Ti4 plus and Mn2 plus. So ionic mismatching is that's for the broadening of the peak is happened. And by using the D-Base formula, the average crystalline size is found to be 99 nanometer. UV visible analysis. Figure 7 shows the UV absorption spectrum of TiMn2 Se5 nanoparticle. In this figure, in the UV range, there is a strong absorption. That is, the photon is absorbed very strongly in this region. There is a sudden decrease in absorption, indicate that the photon does not have enough energy to excite the electron across the band gap, and there is a sharp decrease beyond 700 nanometer, that is in infrared region. So the photon is too low, energy is too low to excite the electron. By using the tau plot, the bandgap energy of the TiMn2 Se5 is calculated as 1.54 electron volt. Then conclusion, TiMn2 Se5 nanoparticle is synthesized by using solver thermal method. From the XRD analysis, the phase of the synthesized material is found to be TiMn2 Se5 nanoparticle. XRD analysis also support the formation of the new phase, and then average crystalline size is also calculated as 99 nanometer. From the UV analysis, the absorption is strong in the absorption is high in the UV region, medium in the visible region, and low in infrared region. By using the bandgap of the TiMn2 Se5 nanoparticle is found to be 1.54 electron volt. Thank you.
Thank you, Audrey, for a wonderful presentation.
Yes, sir.
Single pattern.
Yes, sir. Both binary elements.
You do one thing, analyze your XRD, because if you have two different phases in an XRD pattern, you cannot claim this nanoparticle. You should replace this word by nanocomposite.
Nanocomposite, okay, sir.
Nanoparticle should have the same phase of the so more than
Yes, sir. Yes, sir.
so you ask your guidance, forget it.
Yes, sir.
Then you see you have some big split, major bit.
Yes, sir. Yes, sir.
Then you have some big split. Why it happened?
It's a doublet, showing a doublet in the top of the base, sir.
What is the significance of the double payment?
Spin orbit, it will, due to spin orbit, it will cause. Okay, sir. Thank you.
I invite our next presenter, T. Subbalakshmi.
Yes, sir. We invite Zinat Baseda. Okay. You can.
A very good afternoon to one and all. I am myself Subbalakshmi, PG student from Sadakatullah Abba College. My research title is Exploring the Structural, Optical and Photocatalytic Properties of Salt Cell Synthesis Barium-Titrate Nanoparticles. Next slide.
What do you research?
the synthesis part. Exactly before. The objective of my work is synthesizing barium titanate nanoparticles using Sol-Gel method, and the synthesis barium titanate nanoparticle was analyzed using XRD to study its structural properties. The uptake peaks were well matched with JCPD's card number 812196, and its structure was confirmed as tetragonal. Using Debye period formula, the crystalline size was found to be 21.65 nanometer, and the dislocation density was found to be 2.60 to 10^50 lines per meter square, and microstrate is found to be 1.72 into 10 to the power minus 3. As it was a tetragonal structure, its cell parameters are A and B are equal, but C is not equal. Thus, the values of A and B are 4.0065, and the value of C is 4.0108. Next, please. From the FTIR analysis, the functional groups are found. The left side tabulation shows that wave number ranges from 1041.58 and 486.07 shows the presence of TiO bonds, as well as 860.27 shows the presence of BaO stretching. This confirms the presence of both barium as well as titanate and oxygen. So the successful synthesis of barium titanate nanoparticles. Next, please. From the UV analysis, the strong absorption peak is confirmed in the 275.3 nanometer, and from the top slot, the band gap energy is calculated as 2.87 electron volt. Thus, it comes under the category of semiconductors. Thus, it can be used in semiconductor devices and sensors, etc. Next, please. And it was characterized using photocatalytic analysis. In photocatalytic analysis, I have used direct red dye. It is a kind of azo-based dye, that is a nitrogen-based dye. It is widely used in coloring textiles, paper as well as leather industries. For preparing the dye solution, I have taken 3 grams of direct red dye, and was dissolved in 100 ml of plain water. It was a 0.003 ppm solution. From the 0.003 ppm solution, I have taken 50 ml of dye solution and mixed my synthesis Sol-Gel prepared barium titanate nanoparticle of amount of 20 mg. This was the solution before degradation, and I have carried under visible light, not under UV light. After degradation, the color was this image. Next slide, please. The results of the photocatalytic analysis were this. The absorption peaks were noted for every 10 minutes time interval. At the initial time, the absorption is around here 550 nanometers, and at the end of the time, that is 90 minutes, it was decreased very less due to I have irradiated in visible light, not in UV light. Whether if I have used UV light, the results would be better. And the ratio of initial concentration and final concentration, that is CB0 is decreased moreover better. And the degradation is calculated as only 50%. If we carried this photocatalytic process under UV light, it will give very better performance. Conclusion, from this synthesis, barium titanate is successful using Sol-Gel method, and the structural properties were analyzed using XRD studies, and the crystalline size was found to be 21.65 nanometer. And from the FTIR spectrum, I have confirmed the presence of TiO bonds and barium oxide bonds, and confirms the formation of barium titanate nanoparticles. And from the UV analysis, the band gap energy was found, that is 2.87 electron volt. The photocatalytic activity shows only 50% of degradation. If we use under the irradiation of UV light, it will give better performance. Thank you.
Yes.
Take the average.
Okay, sir. Please.
Did you take X-ray after degradation? Did you do any test for metal after degradation?
Okay, sir. Thank you, sir.
Thank you, Sulashri, for wonderful presentation.
Next, I invite our next presenter, Ms. Shakal Nandini.
Good afternoon all. I am Shimanti, research scholar. I am doing research under the guidance of Dr. J. Daisy Magdalene ma'am. The title of my oral presentation is Spectroscopic and Computational Investigation to the Molecular Structure of 2-bromo-5-nitrothiophene. Result and discussion. The first one is molecular geometry. The structural parameters have been calculated using DFT method. The unsubstituted thiophene ring values are tabulated here. In bromo-nitrothiophene figure shows C3C4S5 causes a greater widening due to the electron withdrawing nature of NO2 group. These deviations from the Mentgenol structure of NO2 substitution can be due to the effect of NO2 substitution. In C1S5C4 became wider because of the weak electronegativity of sulfur, and all the calculated bond lengths agrees well with the experimental values. Next. Vibration analysis. Vibration analysis is used to identify the functional groups present in the molecule. The experimental FTIR and FT Raman spectrum is given here. Serial stretching vibrations are the most effective part of the vibration. The expected values are 3000 to 3100 centimeter inverse, and observed values are slightly greater than the expected values because of the electron withdrawing nature of NO2 group. The experimental values agree well with the expected values of the ring stretching vibrations and the NO2 stretching vibrations. Energy gap analysis. Highest occupied molecular orbital and lowest unoccupied molecular orbital determining the chemical reactivity of the molecules. HOMO is localized over the ring of C double bond C, bromine atom and oxygen atoms of NO2 group. LUMO is delocalized over the entire part of the molecule except some hydrogen atoms. The transition from HOMO to LUMO is given here, and the energy gap value becomes minus 4.3132 electron volt. Molecular electrostatic potential. It is used to predict the electrophilic and nucleophilic sites of the molecule as well as the hydrogen bonding interactions. In bromo-nitrothiophene ring figure shows the red region implies the negative electrostatic potential over the oxygen atoms of NO2 group, and the blue color indicates positive electrostatic potential over the hydrogen atoms, and the predominance of green color is the neutral potential of bromine atom which is attached to the thiophene ring. Mulliken population analysis. Mulliken atomic charges plays a prominent role in the applications of quantum chemical computations. In this figure shows C4 atom has a more negatively charged compared to other carbon atom due to the attachment of bromine atom. Mulliken. Generally, all the carbon atoms have a negatively charged, but C4 atom has a positive charge because of the electron withdrawing nature of NO2 group. N6 atom of NO2 group has a positive charge that shows oxygen atom is bonded on either side of the N atoms. Conclusion. The entire quantum chemical calculations have been carried out using DFT B3LIP with 631G double star basic set. The symmetry of the thiophene ring is distorted due to NO2 substitution and some deviations in bond angles. HOMO-LUMO and MEP images have been performed, and the Mulliken population analysis revealed the charge distribution of electron density within the model. Thank you. In this work, we find biological activity in future. Activity. Thiophene ring, mainly thiophene ring is the activity of antimicrobial and antiviral agents. So in this study, we find using molecular docking and we find biological activity for this compound.
Thank you, Sangal Nandini, for your nice presentation.
Next, I call upon Ms. Abhirami Sundari for the presentation.
I am Abhirami Sundari, research scholar under the guidance of Dr. V. Selvam sir, Government Answers is called Nagarkoil. My presentation topic is super and hyper diffraction in highly excited vanadium nuclei. Introduction. Nuclear physics is a field of physics that deals with the study of building blocks, structure and interaction of atomic nuclei. Sometimes nucleus on excites gives rise to spherical, brolate, oblate in shape. Our aim of this work is to study the shape transition in excited vanadium nuclei, vanadium 53 as a function of spin. This figure shows the relation between shape of nuclei rotating around the z-axis, various values of deformation parameter. Methodology. Our methodology using summation method, the study of rotating nuclei. In the tuning method we have adapted. Then total energy and spin is calculated using resultant discussion. Investigation of structural changes of nuclei at high excitation energy is topic of current interest in nuclear structure studies. To detect the shape transition, theoretically we have chosen vanadium 53 nuclei. This table explains shape and deformation of vanadium 53 nuclei. Consider at different spins up to 60 H class. The spin 0 to 60 H class in steps of 10. The comma value difference minus 180 degree to 120 degree in steps of 10 degree. Beta value ranging from 0 to 1.2 in steps of 0.1. We have considered minimum energy value increasing. The shape of nuclei of ground state can be spherical, brolate and oblate. Sometimes the combined effect of spin and temperature has created a variety of shape transition in phenomena nuclei. This diagram, Godograph as a function of spin vanadium 53. This figure explains the energy eigenvalues are generated for comma ranging from 180 degree to 120 degree in steps of 10. Beta ranging from 0.2 to 1.2 in steps of 0.1. Then finally our results show that in the case of vanadium 53, shape transition occurs from spherical to sharp product at normal spin. Collective deformed sharp product at normal spin. Conclusion. In this paper we have presented the result of shape transition in light nuclear vanadium 53 as a function of the spin. Grant and Nelson summation method we have used in the calculation. Finally, consider nuclei undergo a shape transition from spherical to collective sharp product. Thank you.
Thank you, Abhirami Sundari, for your excited presentation. Any questions, audience?
Next, I invite our next presenter, Ms. Karpagavalli.
Good afternoon to everyone. I am Karpagavalli, research scholar of physics under the guidance of Dr. J. Daisy McTellin ma'am, Associate Professor of Physics, Ranina Government College for Women. Thank you, ma'am. I wouldn't be here without you. I would like to talk about DFT analysis and molecular docking studies of 2,3-dihydroxyguanidine as targeted inhibitor of HPPD. First of all, I would explain the aim of the work. DFT functional theory. DFT is the most fabulous method for calculating the electronic structure of atoms. First of all, molecular geometry. The optimized molecular parameters such as bond and bond angle of the TH2 have been obtained by using DFT method. Then vibrational analysis. Vibrational analysis is to calculate the fundamental vibrations of the molecule. Then homolumo. Homolumo is to calculate the energy and the energy gap. Global reactivity descriptors are used to determine the chemical reactivity of the molecule. MESP analysis. MESP analysis is to predict the reactivity sites of the molecule. Molecular geometry. This is the optimized structure of the THQ molecule. From this structure, C3-C2-O12 bond angle is lesser than the C2-C3-O11. This is due to the OHO intramolecular hydrogen bonding interaction. This hydrogen bonding interaction also supports the biological activity of the molecule. Homo-LUMO, homo as the electron donor and LUMO as the electron acceptor. Homo-LUMO energy gap of the title molecule is 4.723 electron volt, and this energy gap explains the charge transfer interactions within the molecule. Global reactivity descriptors. Ultraphilicity index is one of the most important descriptors which describes the toxicity or biological activity of the molecule. Electrophilicity index value of the TH molecule is 4.060 electron volt, and higher the electrophilicity index value, it has a good electrophile. Vibration analysis. This is the FTIR and FT Raman spectrum of the title molecule. Generally, the overstretching vibrations are exactly around at 3,500 per centimeter. But in this title molecule, the overstretching vibration is 3,454. This is due to OHO hydrogen bonding interaction, and this hydrogen bonding interaction is also substantiated by the molecular geometry and molecular docking study. Molecular electrostatic potential. This is the MESP diagram of a THQ molecule. From this diagram, the positive regions are around the hydrogen atom of the OH group, and negative regions are around the oxygen atoms and nitrogen atom of the title molecule. Molecular docking study. Molecular docking study is an important computational approach, and in this study evaluate the binding energy and the binding interaction between ligand and target protein. The title molecule target with the HPPD inhibitor. HPPD inhibitor is an important protein for herbicide which destroys the green chlorophyll pigment. It is important to photosynthesis in plants. After docking process, the binding energy of the molecule is minus 6.83 kcal per mole. From this investigation, TH2 compound has a significant activity with the HPPD inhibitor. Conclusion: the TH2 compound has and guanidine derivatives are a good candidate for weed management. And this study represents a good starting point for further experimental studies also. Thank you.
Thank you, Karpagavali, for your elaborated presentation. Thank you.
I would like to call upon our next presenter, Ms. Nilofa Nisha.
Good afternoon, everyone. I am Nilofa Nisha. I have done my master degree project under the guidance of Dr. Esther Rubavati ma'am on the title of Influence of Dysprosium ferrous co-substitution on the structural, microstructural, electric, magnetic and magnetodielectric properties of barium titanium oxide ceramics. synthesize my ceramic compound with the help of my guide Esther, and some characterization techniques are under the substance. Powder XRT analysis. From this, pure barium titanate is purely tetragonal, but we have both hexagonal and tetragonal structure in our substance. These XRT spectrums will be matched with our with the JCBDS number and then confirm the hexagonal and tetragonal structure in this substance. These are the morphological analysis by Hedgerton. Our substance in our barium titanate substance is presented in the substance is confirmed by EDX by the presence of our sample in this. This is ferroelectric analysis, PE loop, hysteresis loop. There are electric field is variable from 6 to 50. We have a high remnant polarization as 3.5 at the electric field 50 kilowatt. Magnetic analysis, this is a MH hysteresis loop. ABK plot we have done using the results. ABK plot is a convex curvature. Magnetodielectric studies. From the result we have a graph plotted using origin, capacitance versus frequency, and frequency versus relative permittivity. Then dielectric loss and there is calculated and then it graphed by versus frequency. Then it is a magnetic dielectric constant versus frequency. With a low frequency, we have a dispersion of components and then constant equilibrium. Then it will be some distortions. This is the magnetic constant versus magnetic field. When the magnetic field is increases, magnetic constant decreases and almost to below zero minus negative value for magnetic constant is obtained. Conclusion: barium substance co-substitution of dysprosium and food. And for us, we have both tetragonal and hexagonal phases, but pure BTO contains only tetragonal phase. The microstructural and morphological analysis are done by Hedgerton. In pure BTO, C by A ratio A and B values are equal to this co-substitution dy ferrous component on barium titanate ceramics. The leaky PE loop indicates the Fe concentration in the dy content is a denominator. The perfect MH hysteresis loop is obtained. Then magnetodielectric properties are investigated and then these are used in small electronic devices. Thank you.
Thank you, Nilofer Nizar, for a wonderful presentation. Audience, please keep the silence for 10 minutes. We concluded this session for 10 minutes.
I would like to call upon our next presenter, Ms. Dana Saraswati.
Good afternoon, everyone. I am Dana Saraswati from Department of Chemistry, Raniana Government College, Mangalam. I am presenting a topic on exploring the electrical structure and optical properties of adenine derivative by UV spectrum and quantum chemical analysis. The molecule is theoretically constructed from two compounds. First one is adenine and nucleic acid, and second one is vanillin derivative, which is 2-ethoxy-3-hydroxypentaldehyde. From these two compounds, the shift base is theoretically constructed, and all the DFT calculations were carried out. The DFT calculations were carried out from the minimum ground state energy conformer obtained by optimizing the structure by using the basis set 631 GDP. From the minimum energy conformer, all other DFT calculations were carried out. The UV spectrum analysis shows a sharp absorption peak at 350 nanometer, which is due to the presence of shift base imine group. This peak is due to the pi to pi transition. This proves the conjugation in the compound. From the polarity calculations, we have a value of dipole moment. The 3.56 p-pair of dipole moment value shows the molecule is highly polar and it has a larger separation in charges, and also the polarity value 197 also shows the polarity of the molecule, and it also gives information about the molecule can destruct in the presence of external magnetic field, and the first hyperpolarity value is 4.54 times greater than that of EPR. This shows that molecule is have considerable Ganello property and also used in the photonic devices. The molecular electrostatic potential surface analysis gives information about the electrophilic and nucleophilic attacking site of the molecule. From this, the red color region, a negative region, we have nitrogen 6 and nitrogen 10, which is prone to the electrophilic attack, and hydrogen 23 and hydrogen 24, which is prone to the nucleophilic attack. From MMO analysis, we have HOMO energy and LUMO energy, and also the band gap energy. The band gap energy is 0.16684 electron volt. This much minimum bond gap energy shows the molecule can act as a semiconductor, and the molecule is in highly stable state. Conclusion: from theoretically constructed molecule, the molecule is carried out for the DFT analysis. From the DFT analysis, we have a UV spectrum analysis, which has the peak at 350 nanometer, and the hyperpolarity value shows the molecule has considerable Ganello property. And from having the minimum band gap energy, the molecule can act as a semiconductors. And from MEPS analysis, we have the electrophilic and nucleophilic surface sites of the molecule. And finally, the FMO analysis shows the HOMO energy and LUMO energy of the molecules. Thank you.
Thank you, Yana Saraswati, for a wonderful presentation.
I invite our next presenter, Ms. Shanmuga Sundari.
Hi everyone, I am Shanmuga Sundari, research scholar in Department of Chemistry, Narayana Government College, Rourkela. I am doing PhD under the guidance of Dr. B. Vijayana, Assistant Professor, Narayana Government College, Rourkela. And delighted to present my title, Therapeutic Evaluation of Nucleic Bases, Antibacterial, Antiviral, and Total Bioactivity Profile utilizing PAS online. These are the content of the presentations. Introduction. Nucleic bases and derivative we are using PAS online to evaluate the therapeutic application of the nucleic bases. It helps to identify the potential therapeutic effect and interaction. These are the nucleic base structure that we are taken under the study: adenine, guanine, thymine, cytosine, and lysine. These are the results of antibacterial studies we obtained by PAS online. Among 5 nucleic bases, cytosine have a high activity at spectrophobic species, just normally present in cavities and oral tract infections. Apart from the cytosine, thymine, and lysine have a moderate activity against the exoxyna species, which is normally responsible for plague. Adenine has a mycobacterium against moderate activity against mycobacterium. The next one is the antiviral
evaluation of nucleic bases. Among 5 nucleic bases, adenine and guanine have here highest activity against human versus 1 of thymine kinase. These are the total bioactivity of the adenine. P is the probability of activity. Bioactivity shows the adenine can interact with these enzymes, so it can treat in the DNA synthesis and prepare cancer and diabetic condition. And adenine is also act as a leukopoiesis, which is used to produce white blood cells. So adenine can be used to treat leukemia. And next one is the guanine. Guanine has the highest interactive against peptide inhibitor. So it can use in the treatment of cancer, neurological disease, and also a viral infection, DNA synthesis cancer. And third one is the cytosine. Cytosine has the highest bioactivity against CDP, glycerol phosphotransferase inhibitor. So it can use in the treatment of infectious disease, and is the highest activity against anti-enzymatic properties, which is related to dermatology, used to treat reduce inflammation and itching in skins. Thymine and uracil also have anti-Semitic properties, used to reduce inflammation and itching in skin. Apart from that, thymine and uracil have here testosterone 17-beta dehydrogenase inhibitor. So it can use in prostate cancer and hormone-sensitive condition like PCOS. Apart from that, thymine and uracil here nucleoside oxidase inhibitor and lower peroxidase inhibitor used to treat inflammation disease. These are the research highlights of the work. First, computational prediction of the natural nucleic bases of antibacterial activity. Unmodified nucleic bases as the highest activity against Streptococcus cereus. And second one is the guanine is act as a HHV, human hepatitis thymine inhibitor, rather than the traditional antiviral. Third one is the identification of nucleases as a multi-organ metabolic regulations. These nucleases are real rather than single organ metabolic regulations. Fourth one is the thymine and uracil act as a moderate activity against zoonosis, which is responsible for plague. And fifth one is the anti-Semitic agents. Normally 5-fluorouracil are used in criminology, but natural thymine and uracil not linked to the treatment, so it can highlight the activity of uracil, thymine and cytosine in esotonic activity. And sixth one is the high level of computational studies. Using this, we can reduce the time and uncover the hidden bioactivities and interaction of these nucleases. In summary, we can uncover the potential of nucleic bases in conducting bacterial, viral infection, and metabolic regulations, and even in dermatological conditions. So you can use to pave the way for innovative therapeutic application in natural compounds.
Thank you, Sanvala Sundari, for your nice presentation. Next to present.
I invite our next presenter, Ms. Pushpalata.
Under the guidance of Dr. Vijay Amma, Assistant Professor, Radina Government College for Women. My topic is investigation of antioxidant enzyme activities and biochemical content in cultivars of body variety duplex folding, fluoride and calcium stress. Antioxidant enzyme activity. Antioxidant enzyme activities, SOD, superoxide dismutase, catalyst, APX, GPX and GR of paddy fresh leaves once in a month analysis. After harvesting of paddy, the biochemical content carbonated and totally in the analysis in rice. Calcium fluoride concentration increases to antioxidant enzyme activities is increases. Antioxidant enzyme activities increases in reactive oxygen species value is up controlled. Reactive oxygen species value controlled in reactive oxygen species value controlling damage of cellular components and plant growth increases and yield in increases.
GPX. Glutathione peroxidase enzyme activity equal in detoxifying hydrogen peroxide and organic peroxide in unregulated in response to fluoride-induced oxidative stress. Calcium ion play a crucial role in activating GPX and elevated calcium level. They further enhance its activity, thereby aiding plants in exterminating fluoride-induced stress. Then biochemical content, carbohydrate and protein content in calcium fluoride concentration increases to biochemical content in decreases. Carbohydrate content decreases in this suggests that calcium play a productive role in maintaining carbohydrate content and explanatory fluoride induced stress. Then protein content. Fluoride stress reduces protein synthesis and stability in life, while calcium helps mitigate oxidative damage. However, excessive calcium stress may still impair protein content. Then conclusion. In the present study, these findings suggest that calcium plays a critical role in mediating antioxidant response and alleviating fluoride-induced stress. Then, however, the effectiveness of calcium in protecting plants from fluoride toxicity is influenced by the concentration of fluoride and the extent of the stress. The ability of calcium to enhance plant resilience to fluoride-induced oxidative damage may vary depending on the stress factors. It also will be a significant reduction in carbohydrate and protein content due to oxidative stress induced by fluoride calcium ion in cholesterol sativa in Durex protein varieties.
Thank you, Pushpalata.